Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they are live, and most importantly, if you would like to join the debate, with the page you are currently listening to me on muted, simply click the link in the info box to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you will be ejected, and if you are, please do not try to rejoin the stream using sock accounts. You will be warmly welcome back on the next stream. In a moment, I'm going to transition across straight to the Hangout as we do have a guest, but in the meantime, if you could share this show, as obviously it increases the live audience, but that in turn does increase the chances of having a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. And with that, I'll introduce our first guest, which is Sleeping Warrior. How are you doing, Sleeping Warrior? Good to have you here.
Hiya, pal.
Hello.
Just, I thought I'd open it because if I can get on first, I can normally get things that I want to say before it ends up being too busy.
Just watched your video.
The Isle of Man video has been out for the best part of a week, and it appears that there's been nobody that's actually debunked it, and I say that word loosely. Is there anybody that can debunk it with something credible other than simple dismissal?
We've got Chris FE here, just to say a quick hello. How you doing, Chris? If you can just... I think you've got two...
Hey, mate. How you doing?
Are two different Chris's?
Can you hear me?
Oh, we've got two Chris's. Sorry, Chris. I've got Chris and Chris.
Oh, do we?
We do.
Oh, so we do.
We do indeed.
Chris FE, how you doing? All right?
All right, how you doing, mate?
We've got Ali B as well. How you doing, Ali B?
How am I coming through okay?
You are indeed.
You're fine, Ali, aye.
Loud and clear.
All right, guys. Hi, Chris. Oh, two
All right,
Chris's.
Yeah, pure so.
Anthony. Thanks, Nathan.
Pleasure. Good to have you all here.
Cheers. Well, at least it's not two alleys.
Oh,
Dark
sorry.
one and a light one.
Hi, Anthony. I'll let you carry on, mate. Sorry.
No, I'm just wondering if there's anybody out there that can actually debunk it. I mean, it's been out for a while now, and all I see is dismissal and rejection. That's not proving it wrong. So, again, I think that Nathan puts it best when he says, where is the curve? We are still seeing stuff. That lighthouse, for instance, is the first artifact on the island. Shouldn't even be visible. And that's before we start panning left or right. So come on. Where's the debunking proofs? Somebody come and try and show where we've got this wrong, why it appears to be flat. I'm sure Chris can sort something out.
Well, again, I can't make pronouncements and images I know nothing about, and I wouldn't want to.
Oh, and I'll just correct the record because Curved Water is claiming that I've admitted that the heights are that I've misrepresented the heights. That's not true. I've put the heights in as per Google Maps, Google Earth, and the height that is put on Google Earth is what everybody does. Whether it's correct or wrong, from my point of view, is completely irrelevant. I don't care. This is your model. This is what your model tells. So if it's wrong, it's nothing to do with me. It's to do with your model. And I still stand by the 35 feet. I'll give you it up to 50 feet, but I'm happy with the 35 feet because at the ground level or the lower level at the car park area right in front of those caravans is about 20 feet. I agree with the 20 feet. I agree with the 35. I'll give you 50, but you need about 1,000. So, Curved, stop misrepresenting my words.
How did you arrive at the 1,000 feet exactly?
I fed the numbers back into the
What are the
Earth,
numbers?
the Earth curve. Yeah, I'll share my screen and show it.
What he done, Chris, is he measured the distance from where he was to the Isle of Man, done the curvature with the refraction, and there was a 1,000-foot deficit there. That's how he done it. So,
yeah, I mean the furthest point was 50.3 or 50.7 miles. And whether you put it at 35 feet, 50 feet, or 100 feet, it doesn't really make any difference.
That's at sea level. That's at zero elevation.
Sure, but my point is that the furthest point left was measured at 50 point something miles. Now, I want you to watch this because you can see my screen now, yeah?
like, do you know something? I can, right? I just want to say this before we get in. If we do this again, and I use the word again because we've done this like 4 times, and you know, not.
Yeah, that's because you can't get it into your thick skull. It's because
Right.
you lot can't get it into your thick skull.
No,
When
but
you-
it just seems that the
Anthony-
flat
Anthony
the flat Earth
decided-
side seems to set the agenda for what we discussed tonight. I frankly would like
Well,
to
it's a
talk
flat
about
earth
the
debate,
equinox.
mate.
I know
But
that.
you don't know nothing. But you've saying I don't know nothing. You won't comment on anything.
Can't make
anything.
pronouncements on something I know nothing of.
Well,
But
let me
exactly, but you're making pronouncements by you're going to criticise what Anthony's just about to say, and you don't have a clue what he's talking about.
I'm just saying that we've been over this several times.
let me just address the 1,000 feet
And
point.
we'll keep going over it till you get it.
Yeah, because everybody asks, where's the evidence of it being flat? Well, this is pretty persuasive. The point is at 35 feet, it's 1,000 feet in observer height. Now, if I put that up to 50, remember, I'll tell you what I'll do here. Just so that we
Even
don't-
the live chat wants a different topic. They're sick of it. I'm sick of it.
Yeah, well, it's flat Earth proof, mate.
It's nonsense.
Well, it's kind of all over your argument, though, isn't it? I mean, the evidence for ball
Let's
Earth
talk
isn't
about the
strong.
equinox.
Well, debunk
Or-
it and we can move on. But I want to show you why.
Paul and the Rumpus have got into it in great detail, and I'm pretty satisfied with what they've
No,
said.
they've not.
Especially
What they've
what
done
Paul
in
said
great
today.
detail.
And
Sorry,
you know what?
just to
I'm not
correct
even
you.
that
They've
sure
not gone
what
into it.
we're
You want
talking
to
about.
end this conversation?
Well,
I'm
let
going
me-
to tell you right now
let
that
me
Rumpus and
address your 1,000
Paul
feet.
have gone into great detail about how mirages work mathematically. Well, first and
Right. Well,
foremost,
then we'll be at a deadlock then, because we won't be able to agree. You won't be able to accept
Maths.
atmospheric
well, hold on.
refraction.
What is it that we have to accept? You tell me, and then by you telling me what I
Well,
have to
from
accept.
from what I understand, refraction is,
Negligible.
no.
Well, no, let's just hear his answer. What is it that you
No.
think we haven't accepted?
Seems to me that refraction and lumens certainly have a part to play in this, and if you're saying that, as Anthony says, negligible, then I don't see how we can move forward.
Okay, so you've said refraction and looming. What about them? What necessitates them?
I don't know. That's what I'm saying. I can't speak to that.
fine,
don't know
I
enough about
can,
it. I'm not
and
an
I'm gonna-
atmospheric scientist.
I'll do my damnedest to explain it to you because it's very, very simple. The reason they must have refraction and looming and what I term as holograms is because in your model there is 1,000-foot wall of Earth between us and the target object which we can see in the photo. So for it to be in the photo and for it to fit on your model, there must be refraction and there must be looming. Now that's because there is 1,000-foot wall in the way. And what we are saying is we see no 1,000-foot wall and we see no evidence of looming or refraction. Where we do see them, they are negligible. Excellent
Okay.
timing.
But where can you get that from?
The
Where do you
photo
get-
itself.
How
You
do
can get it
know
from the
that
model
how do you know
in
it's
the maths,
negligible?
which you've just been shown. It said 1,200 feet obstruction. Well, there was no obstruction. We see all of it. We see the village. We see the lighthouse. We shouldn't because there's 1,000-foot wall of earth curve blocking our view. Therefore, for you to believe that you're on a ball, you must see looming and you must see refraction and you must see mirages and you
do
must
see those
believe
things,
that
though.
it's a
We do see
hologram
those things.
because you don't
Okay.
have
Have you-
line of sight.
Okay, well, the only
There's
other-
something
the only
in
other
the
reference I can
way.
point to
I haven't
is-
finished. There's something in the way. Do you understand what's in the way of those things that we see? Do you understand, yes or no?
Understand that there's curvature in the way, yes. But
Right.
I can't.
1,000-foot
Okay.
wall of it.
I cannot.
So
The only other example I can think of offhand
Why is it
is
1,000
the
foot?
Chicago's. I don't know. I
Right,
don't know.
so we're getting somewhere,
That's kind of
Chris. So you
important.
understand that there is 1,000-foot wall in the way of the things that we are seeing.
Why is it 1,000 foot though?
You tell me why it's 1,000 feet.
Because that's
I'd
what
like to
your
know
model says that should be, but is not blocking
But
our view.
how does the model say that, Nathan?
Because that's the calculation that we've brought up on
When you're
screen about
standing on the
20
ground
times,
with no
Alex.
elevation.
Are you going to really chime in and we'll count the number of times that I've had to explain this to you, Alex? You and Lou,
well, no, don't explain
you
it. I'll
and
explain it
Lou
back to you.
represent the slower
That
people here who
calculation
still haven't
comes
got
from
it.
Being on the ground, like with your face on the ground.
You don't need to troll
Yeah, but
here,
what-
Alex. You represent the people that don't get it.
Well, no, because we did it on the calculator, didn't we? And
Oh,
if
we
you,
did it
if
on
you
the
like,
calculator.
make
You
a
don't get
place
it,
in
Alex.
the
We
air,
all
100 foot,
understand.
yeah, it's
Most
not.
of
It's
the
like
viewers get
120
it.
foot, isn't
Most
it?
of the viewers ask me, why doesn't Alex understand it? And I say it's cognitive dissonance. They can't get it.
Well,
They
no, you're not going
think.
to answer my question, Nathan.
Right,
Right,
I'll
I'll
answer
gish
your
gallop
question.
over me. Because
I'll
no,
answer your question.
yeah, bring the calculator out.
Right. So Nathan, do you
Well,
want to present
Alex,
this? It
Alex
stays-
doesn't get it because he's already.
No, I don't
admitted
get it. Well,
he's
explain
dumb.
it to me then instead of
He's
gish
dumb
galloping.
and doesn't
Oh,
know
Alex
anything
doesn't
about
get
the
it. Just
subject.
start teaching
I
it
would
to me
actually
then.
like to know where the
Try and
photograph was
convince us
taken
of
from,
something.
because I
That's
don't
why
know.
Alex can't
Oh, yeah,
answer
you're going to
it.
chime in now and make it
He's
like
dumb.
not answer.
And he's
Just
just
I don't
answer
even
the
know where the
question.
photo
Where
was
are you
taken
getting
from.
the 1,000
It's simple.
feet?
Do you see this word here? It says hidden. Do you understand what the word
Yeah.
hidden means?
Yeah, so show me. Oh, hang on, I
Hidden.
can't see it. Hang on, I'm on
What
the
do you
Where
mean
was the
show you?
photo
We
taken
can't show
from?
you because nothing's being hidden, Alex. That's the
Yeah,
problem
and
for
we
you
don't know you're at
Globers.
35 feet. This is the problem, isn't it? And you're saying it's 50 miles. Is
Yeah,
it
but whose
50
problem is it though? Whose problem is it?
Where,
It's not our
Anthony,
problem.
Where was it?
We
Where was
just
the,
see
where was the
what's
photo
there.
taken
The earth's
from?
flat. You mental heads.
Nate,
Why was
is that my screen, mate, so that it stays on?
Guys,
It is.
come on.
where was the image taken from? By whom and when?
Yeah,
Right.
you can't get the feet. We're still arguing about your 35 foot. You know what I
Right.
mean?
Well,
And you-
anyway,
you've got-
Alex,
you've got
we'll
the
come back
cheek
to you
sit
because
there
there's
and
a
say, "I
whole
don't get it."
bunch.
Oh,
There's a
you
whole
just
bunch of
don't
new
get it.
guests, Alex.
It's
So
a
I'm just going to do.
1,000-foot wall in the way.
Alex,
it's
get
just
over yourself.
insane.
Get over your
Yeah,
ignorance
get
for a
over
few
your-
seconds, Alex. I need to
Listen
introduce
to
some
Guys,
people.
please tell
Alex,
me
Listen
where.
to yourself,
Get over your
man. You're
ignorance
the
for
one
a
here.
few
You're trying to
seconds, my
moderate a
friend.
debate, and what
I
you're
know
doing
you're
is
triggered. I
insulting,
know
kicking
this is
shouting over
upsetting.
people.
Not understanding
triggered,
things is
man. Just
often
think about
upsetting
it.
for people. But I need to introduce a few
about it,
guests.
mate.
If he doesn't do it, I'll
Alex.
do it for him.
Yeah,
Alex.
Go ahead,
that's what I'm
Nathan.
saying.
Right. First in was David. How you doing, David? Good to have you.
Good. How about buoys? If you put buoys out there and you hooked them to the bottom of the,
We'll come back to you.
on the
I promise,
bottom,
David. We'll
underneath
come
the
back to you,
water, right?
buoys. David, Brenda, how you doing? Good to have you, Brenda.
Hi. You guys still trying to prove the Isle of Man is really Ireland?
Apparently, yeah.
No,
Right,
we're,
we'll come
we're
back to
waiting
that
for
too.
From an unsourced,
Hold on, we're nearly there. We're nearly there. Bear with me. Philip, how you doing? Good to have you, Philip.
unsourced photograph that we
Brenda,
have no,
bear with
no
me. Brenda,
verification
I can
of
get
how
through this in
That's why I'm trying
seconds,
to pin down
or
the
I have to
details,
talk
yeah.
over you for 5 minutes. If you just button it while I introduce the last two people.
All
Right.
right.
Philip, how you doing?
Hi, how's it going? Can you hear me?
Yes, perfectly.
Yes.
And last but not least, Paul, good to have you here, my friend. How you doing?
Yeah, good.
Right,
Thank the
Paul.
Lord. Thank you for your patience.
Hi, how are you?
But can you guys just tell me where this damn photo was taken from, by
Sure.
whom and when?
All right, I'll help with this. But before I show you the photos, let's just address the observer height issue, because we're seeing 50 miles. Paul will attest to it. We're seeing 50 miles in the evidence. Now, at 35 feet, and we're going to put 3 figures in here to see what happens, okay? So I don't care which figure you go with, but at 35 feet, the value down here is 1,016 feet of obstruction, okay? Now, if we put 50 feet in there, which is the highest point according to your model that I could possibly have been, it only drops to 944 feet. The land that we can see is only 50 feet in height, so that's not going to cover it. But what we need to do is, if we put the 1,016 figure back in, 1,016 feet, then we can just about see the tops of the land. So even if we go all the way up to 1,000 feet, the obstruction height, the observer height that's necessary to see the land that we can see in the evidence means that I need to be 900 feet in height.
So hang on, it's like hidden 80, yeah.
So
That's not a lot.
it's 1,000 feet. That's prominent. So with regards to the evidence, the footage itself, this is taken from somewhere on the hill. Now, Lewis wants 50 feet, but I'll give him 100 feet. He needs 1,000
Yeah,
feet. of
it was
curve.
100.
The hell from where?
Well, this lighthouse, for example, I think was 31 miles away.
Is this on Scotland?
Oh,
Is this
alright,
in
so plug in
Scotland?
31
Is this-
miles then, right?
is
Plug in
this-
31 miles and 100
Yeah,
feet.
let's do
Is this-
31 miles.
No, do it.
Is this
Plug in
image been
that-
taken from Scotland?
No,
That's
it's
the
been,
Isle of
taken,
Man.
It's been taken from the Isle of Man.
it's been taken. No, it's been taken from Whitehaven in a town called St. Bees. Whitehaven is on the west coast of England, and it's the north side of England.
Right, okay. So it's been
Right,
taken on
right.
mainland Britain.
Plug in 31 miles and 100 feet height, like you said.
Yeah, can we
Well,
can
I
we just like focus on one particular target for now?
This is what, yeah, exactly. So we've got a
See,
target,
that's the thing.
31
I've
miles
been
away.
asked
We're going to give us 100 feet because you said
So-
you'd give it to us. Let's see
right
it.
from there.
What's the obstruction?
It's 31 miles in distance, and the
Yeah,
highest point, according to your model, I mean, it was along here somewhere. It was about. It was either this jutty out bit because you can't stand right on the edge because these erosion will collapse under you. So it was either there. So let's put it to where it was.
Okay.
It's either there or it was there. But in any event, the difference between the two on your model is 37 feet to 33 feet. It's only 5 feet of difference. But the highest point is 50 feet. But I'm prepared to give you 100 feet just to make you feel as though I'm not being dishonest or misrepresentative. However, I agree with the values that are on here.
The problem is, though, Anthony, and I've said this before, how do we get the target heights? Because we have to get the target heights from somewhere. And unless we're prepared to ignore the target heights as well and go with, you know, using fence posts, as Lou would suggest, to measure the target height as well, you have to use the same for both. And if you're going to use Google at the target end, you just use Google at the observer
Why don't we
end.
just plug in these values? What's the matter? What's so hard to do?
That's how high it actually is. So this is the lower car park height, where the lower car park height is this part here. This triangular patch, I'm at the bottom corner here, that's just about to walk up the path. So if you look at how high this is in relation, this is the beach where the rocks are at the bottom. That is claimed to be 20 feet. I agree with that looking at 20 feet, because if you get these caravans and you can stack 3 of them before, maybe 3.5, before it gets down to the rocks.
4 in the picture. Wasn't even near the
They're not the caravans that you're above in your video, Anthony.
Yes, they are, because if I show you the actual...
No, they're not. The ones are on the other side.
Yeah, they are the same caravans. Watch. I'll show you the other video. So, St. Bees, where are you? There you go. So, on this particular video, let's get rid of that. This is showing you from where I'm taking the film from, where I've just been, which is that car park where the photo was just showing you with the rocks. That's where the that last picture was taken from. And all I've done is I've walked up the path. There's the height of the caravans, and I'm at the little path there, the little jutty out bit. And then basically, as I go through,
that looks
it looks like
pretty elevated
pretty
to
far
me.
out there.
So,
yeah,
so we're gonna put,
look up.
You're gonna put those numbers in though. Come on, because Nathan's saying it's 1,000-foot wall. We got to show him this. He's saying I don't understand it, but I think you should.
The point of where you've taken that video there is about 100 feet. I've got a map that shows the contours that actually shows the elevation at that point.
He's going to give us 100 feet, Paul.
Sure. If it doesn't show that it's around about 30 feet, Paul, you're admitting that your own model is wrong. So I don't care what value.
You said we can have 100 feet, Riley. So can we plug it in?
We can have 100 feet. You need 1,000.
Can we do it then? Well, no, let's do it with 100
I
and
don't
31
think we need
miles.
1,000 for 30 miles.
Hold on. Paul says he's got another reference. If it's got the target height on it as well, then we're golden. We've got something else to go from. That we've got both target height and observer
you can
height.
have the 100 feet. However, you have to concede that you're putting in figures that are inconsistent with your own model. And that by definition,
you said we can have 100 feet.
Wrong.
You said you're confident we can have it. So let's put it in and see what the obstruction is. This 1,000-foot wall Nathan's talking about.
This is where I was. But even if I was here, it's like 3 feet higher. Right, 36 feet. So if Paul's going to produce evidence of 100 feet,
you're not going to put it in, are you?
Well, I can produce evidence of 100
Let's just
feet.
go with that assumption because it doesn't. I guess you're very confident in your argument here, so let's just.
I'm just applying your model. This isn't my model. I'm not making any assertions other than your model tells me I'm at this height. So
no, you know that.
Well, that's the
Google Earth
sea level.
Yeah, but this is your model. This is what Brenda tells everybody, that she's got a model. She's got a model. Well, the model doesn't do what you tell everybody it does.
Because the model, this is
and you know also that Google Earth tells you not to expect its elevation measurements to be correct.
I'll give you 100 feet without a quibble, provided you accept that you're putting in figures that your own model doesn't support.
Right, just put the 100
We're
feet
talking
in.
about an approximation.
Well, in that
it's
case,
an approximation. It's not the real thing.
In that case, then we put in what it says, 35 feet.
Can I just ask something?
You said you'd give us 100 feet. Put it in.
Anthony, why didn't you get your GPS out and take a GPS reading?
Because I originally went to do this observation looking for Blackpool Tower, which was immediately behind me. I wasn't going up there to do this.
Can I ask a question? Are we accepting 100 feet and the distance at 31 miles?
Yes, Brenda.
Provided to me.
Provided that everybody agrees that we're putting in.
No, we just put it in. Someone else can put it in.
We're putting in figures which don't do with Google Earth. Okay.
Could Nathan share my screen?
Riley, you're gonna have to get two people on. Get somebody over on that island with a reflector, with the reflecting the sun with a mirror or something where you can film them.
You're sharing, Brenda.
Here is eye height 100 feet, target distance 31 miles, obstruction 234 feet. That's H1. This value right here.
Right.
Yeah. So in relation to
Not
the
not
lighthouse,
1,000 feet.
Not 1,000 feet.
Not
Nathan's
1,000
saying
feet.
we don't understand and he's
200.
laughing at us.
200
How
feet.
does that graph work
Can
if
you,
you have
can you
Hang on,
apologize
hang
to
on.
us all
Let me
now?
answer-
Okay, guys, just
yeah, buoys
relax.
out there
Hold
against
on.
the water? How does it work?
let me answer Brenda. Brenda, the 31 miles relates to the observation of the lighthouse. That's the nearest artifact to us. That lighthouse would still be completely missing by that math that you've put on. That's based on 100 feet. Yet we see it in the evidence.
So
Can I
high
just
is
ask
we
Brenda
do.
to?
How
Sorry,
high is
bear with
about
me a
that
second,
later.
guys, because Brenda was just addressing that to me. So I just want to address what she's got on screen there. So correct me if I'm wrong, Brenda. There should be 234 feet of Earth between us and that lighthouse. We should not see the lighthouse because Earth's in the way, but it is not.
Well,
correct?
Nathan, you were saying
I
it was
don't know.
1,000
Now,
feet
this is
earlier.
where
You
things
were-
are-
Hold on, everyone's talking over Brenda.
Ridiculous.
Hold on,
Nathan,
hold on. I
Nathan,
want to
you're
get an
dishonest.
answer from
You're a
Brenda. I'll
dishonest
ask her the
person,
question
Shane.
slightly
And you
differently.
knew
Brenda,
everything.
according to what you've just shown us,
Yeah, thank you, David.
H0 is how high we are above the water.
I understand what you've
H1 is the
explained,
target,
Brenda. I would
and
like you
it
to
is
just
not
clarify for
1,000
the
feet.
audience.
Brenda,
There
explain
should
to me how
be-
that would work if there were buoys
There
out
should
there
be
on-
234 feet
Tried to
of
break
Earth
it.
blocking out. Oh, she seems to have stopped screen sharing all of a sudden now that I want to use her point against her. So, Brenda, there was
Oh,
200.
I'll put it back. I thought we were done. I'm
Excellent.
sorry.
No, Brenda. So we'll clarify this for the audience. There should be 234 feet of Earth
Correct.
blocking our view of the lighthouse.
That would be above the level of the sea level.
How high is the lighthouse?
So,
That
Brenda,
is-
maybe
so now,
maybe I'll
Nathan,
ask Brenda
Nathan,
this
can I-
question.
How high is the
So,
lighthouse?
Brenda,
Can I come in?
where
Okay,
is
never
that curvature?
I don't know anything. I have not been watching your shows, so I don't know even what you guys are
So
talking about.
why do you even have
other
a
than-
horse in this race, Brenda?
This
If you're
is where the refraction
Is
comes
Is this
in.
the argument that we get whenever we get to a
want us to
difficult
correct
question? It
numbers.
seems
These
lots of
This is
people
what I
talk,
know
and
as
people
well,
like
Brenda.
Brenda say they haven't been
Can I-
looking.
I've been
People like
following
Brenda
this for a
suddenly
while.
haven't been
I
paying
actually
attention
like
when
to
a
talk
difficult
a little
question
bit
comes
about
up.
this.
So you haven't been paying attention, Brenda. So why do you even have an opinion, Brenda? Why do you even have an opinion? Because your opinion so far basically supports our entire argument.
No,
Because
you said
you've
it
taken
was
the figure
1,000.
down again.
Yes,
You
but-
seem to
said it
have
was
taken the figure
1,000?
down again, Brenda.
The flat earthers just won another one, Nathan. Let it go.
It's okay. Brenda's taken the figure down that absolutely 100%
How high-
supports our argument that there should
Nathan.
be a massive
How
amount of
high-
Earth curve in the way and is not.
Okay, Nathan, can I talk for a second?
yeah, sure, go.
So
How high?
so the assumption that you're making is that light travels in a straight line.
Oh, please.
And
That's
that
not the
is
question I asked.
Assuming that
No,
the
we
index
haven't got
of
on to that yet.
refraction is
No,
constant.
Philip, sorry. You're being very unreasonable there. That's not at all what I asserted. So if you want me to rephrase it for Brenda,
Okay, go ahead.
do
I'll
we
listen to
have
them.
line of sight with the lighthouse?
I don't know. I haven't seen the video.
Based on the maths that you have just done for us, do we have line of sight with the lighthouse?
I don't know. I don't know how
You've just
high
done the
above
maths.
sea level
You have
it
just
is.
done the maths
All right,
and
so-
shown the audience
Brenda,
how much
I'll
was...
answer that one for you.
Philip, sorry.
Nathan's
You
been
said-
completely disingenuous.
There's
Nathan's
a
been
difference
completely
between how
disingenuous.
tall it is and how high above the sea level it is right?
Well, you've just
I
shown
don't
the
know
maths
how
that would
far
show that
above
there was
the sea level
230
it's
feet
built.
obscuring our view. Have you not?
What
have you
about
not
the
just
land it's
demonstrated
built
that?
on? What
Have you
about
not-
the land it's built on?
Brenda, it's actually hidden. So if you look at it geometrically, the lighthouse is below the horizon.
What do you mean if you look at it
I haven't
geometrically?
seen.
It is. I've watched the previous videos. The lighthouse is what, like 100 and...
It's
The
Seven-
lighthouse is
seven-
213 feet in elevation.
75 feet is the height of the lighthouse, and it sits on rocks that gives it a focal height, which is the height above water of 213 feet.
Oh dear.
Okay.
That's correct.
Ding ding,
That-
knockout. See you later. This is what I mean. You just don't understand it. You're prepared to
Thank you,
call us
Brenda.
idiots. and stuff.
Thank you, Brenda. We
But
appreciate that.
Cat, you are an idiot. You are an
Oh, am
idiot.
I? Well, I just pulled this one out, didn't I? You didn't understand that. You trying to tell me
You've
it's 1,000
admitted you're
feet.
an idiot.
Last time
Cat.
you were calling me an idiot, you thought it was a 1,000-foot wall.
You've
in
admitted
there.
it. You've admitted
Yeah,
it.
yeah,
You're
Nathan,
an
yeah,
is
idiot.
being,
whatever, man.
Nathan is being completely
Smoke another one,
disingenuous
buddy.
here. He
This
knows
is
that
completely
according to
and
the standard
utterly
model of
unproductive.
refraction, according to the standard model of refraction, Nathan knows that it's hidden. Okay, but viewing
Nathan
across
knows that it's hidden. I can see
35 or
it, Paul. What are you
31.5
talking about? Why are you telling the
miles
audience
of
that I know
water
it's hidden?
is not
Sorry, Paul, I'll talk
standard
over you because you've just put
refraction.
words in my mouth.
What evidence
Why
have you
have you
got for
just
that,
told the audience that I know it's hidden when I can see the damn thing? You're trying to put your fantasy onto me. Paul, I don't know it's hidden. You must have it hidden on your model. That's not going to put. You're not going to put words in my mouth, Paul. Absolutely not. I don't understand that it's hidden. I can see the damn thing. You must accept that it's hidden because it doesn't fit with your model if it isn't.
No, we have to accept that light curves.
There is an
That's the only thing
obstruction.
we have to concede.
Paul, is there an obstruction blocking our direct line of sight with the lighthouse or not?
That's assuming that light goes along your direct
It's a
line
simple
of
enough
sight.
question. Would you like me to repeat it? It's a simple question. Do we have direct line of sight with the lighthouse? Yes or no?
We do because of refraction.
That's not
Now, what
direct
do you
line
mean
of
by
sight.
direct-
That's
what
a
are you gonna
refracted
do?
line of
Direct
sight.
line of-
Paul,
I have
that's a
calculation
refracted
which
line of
shows
sight.
that light refracts.
So we do not
How
have
about
line
if
of
you lined up
sight.
35 bueys all the way
Paul,
across one of
we
mile
do
apiece,
not
would that
have.
be level across there?
When will
David,
Paul
David,
admit to
my
it?
problem
Why is
is-
Paul struggling to accept that there is a wall of earth
No, I'm
curve
not
blocking our
struggling at
view?
all, Nathan. You're struggling
So
to
say it.
understand.
Say it.
Paul,
Say there's something blocking our view of something we can see, Paul, for the audience to hear.
Flat Earth buoys.
Are you talking
Proof
about
flat Earth.
geometric
Say it.
breakdowns?
Let me
Nathan,
hear
Nathan.
you say it. Let me hear you tell the audience. Let me hear you tell the audience that there is an obstruction between us and that object that we are targeting. Tell them that there is an obstruction.
Obstruction.
Yes.
That is not.
Let me hear you say it,
Now,
Paul.
we're going to go from here, Nathan.
Do you understand that there is an obstruction, Paul? Let's just see if Paul, maybe Paul doesn't understand this. I need to understand your understanding of this, Paul. Do you understand that there's an obstruction, Paul? Do you understand that?
I understand.
If I apply for
Paul,
Nathan.
Philip, you're not
I
being
know
spoken
better
to,
than
Philip.
I-
I'm trying to
lot
tie Paul
better
down
than
to
you
this.
do.
Been trying to tie him down for a long time. So, Paul, you appreciate and understand that there is an obstruction blocking our direct line
Yes,
of
Nathan,
sight with the
there
lighthouse.
is an obstruction, Nathan. Yes, there is an obstruction.
But we can see it perfectly
Move
clearly,
on.
Paul.
Light moves in
So,
a straight line.
okay, so now
where
we're
is
into
this?
mirages and holograms and
Mirages
looming.
exist.
So, now...
Don't go off into that garbage.
Mirage
Well, I
exists.
agree it's
no
garbage.
need
So
to
you're gonna
garbage.
now tell me with the
I'm
picture on
perfectly
screen,
fine
Paul,
with saying that
where
mirage
these
is
effects
real.
are.
Mirages to explain it.
Right. Yeah, let me ask
Those
Paul
are
a
the
question.
terminology. That's the
Paul.
terminology you want to use, Nathan.
I use whatever terminology I like,
Not the
Paul.
terminology we want to
Paul.
use.
I'm gonna call them
Let me ask you a
holograms.
question, Paul. Just give me a yes or a no. Does light only bend down with refraction, or can it bend up as well?
No,
So, but light
can
can
bend
bend.
in
It depends
any
on-
way, depending on the conditions.
So light can bend up as well, yeah.
Yes.
It can bend up, it can bend down, depending on the conditions.
Okay,
And
Paul.
that's
So
usually
Under
something that
standard,
I'd like
light
Paul-
bends
I'd
down.
like Paul
You've
to
seen light
explain.
bending down in a heat
Paul,
wave.
Paul, just
Why-
for
why
Paul's
does it-
attention,
why is light
Paul,
calculated for down,
Paul, if
Paul?
you're listening to
So I guess
this,
the question here really is, Anthony.
no,
what
I'll ask
are
the question, Paul.
conditions?
Paul, where
No,
does the
Paul.
refraction
Why is it a
begin?
calculation always going down on your model?
It
Does
is
light
not
come?
always going
Because
down if you put the correct
it says
conditions in,
so.
Anthony.
It's always going down, Paul.
Anthony, have you seen a heat wave in a road? Have you seen a heat wave in a road that looks like water on the road?
Can you show me that example here, please? Is that Chris speaking? Chris, can you show me in this picture that I'm demonstrating where the refraction begins and where it ends?
No, I
Because
can't.
you can't.
Can't.
That's a stupid question, Nathan.
Well, that's what we're
Right,
talking
Paul.
about here.
The
You're
refraction
saying,
doesn't begin, nor does
Paul,
it end
you're
everywhere.
telling the
It's
audience that
continuous
something is
along the
blocking our
whole
view. Should we ask you
line.
again to clarify
You're
this?
asking me.
You've
to
already
make
asked you.
pronouncements
You've
and
just
things I
told
know
the
nothing
audience,
about.
Paul. Can you stop talking over me? You've just told the audience that there is something blocking our view of this lighthouse. Yeah. So now I want you to show me on the picture where this evidence of refraction is. Where does the looming begin and where does it end, Paul? You tell me.
That is a stupid question.
Why?
looming
That's the
doesn't
photo we're
begin
talking
or
about.
End anywhere. The whole image is raised up.
My
by
wife
looming,
wants to know why it's a
Nathan.
stupid question.
What evidence have you
Stop
got to
talking
prove
over him.
that's the case, Paul?
Are you expecting that one part of the image is affected by refraction while the other part isn't?
You
That's
tell
just
me you're
garbage.
the one
That's
who's asserting
stupid as-
refraction, Paul, not me. I just say we see it all clearly as the rest of the picture. It's all as clear as the rest. You tell me which bit's
You say
refracted
we see it all
and
clearly.
which
I
bit.
say we see it all raised up in elevation, Nathan.
You say,
well, can you
right,
prove
well, we
That's what
do have, this is the thing, Paul, we do
Who
have
told
direct
you
line of
that?
sight with some of
Who
it.
told you
So,
that?
Paul,
Who told you
Paul,
that?
where does the direct line of sight begin and where does the refracted line of sight begin?
All light is
That
refracted.
once
to
again
the
is a
atmosphere.
nonsense question.
There's no
The
line.
whole image is raised up by looming,
Where'd you
Nathan.
learn that at? Tell us where you learned that at.
So
I learned it
even,
from the
hold on,
paper that
Paul, so the
Riley
whole
cited.
image, including what we have direct line of sight, is raised up.
Everything is raised up, Nathan. Which part don't you understand?
No,
Paul,
I'm
we
getting
know
there,
that
Paul.
you
I
said
understand what you're explaining. I don't accept it, but I'm just trying to
Even
get to the end of
the
it.
top, even
Paul,
the- well,
hold
that
on.
does-
I
I don't
haven't
care whether
finished.
you accept it or not. That
I
is
do-
what
How do you know
happens.
that?
So, Paul,
How do
my
you know
next
that, Paul?
question
The
is
whole
the
image is raised
effect
up,
that you are describing linear along the picture? So, do we have the same effect?
No.
We don't. Why not?
It depends on
The
the
whole
atmosphere.
image
Oh my God.
is raised up.
Yes,
Can you
and is
prove
it
that,
raised
Paul?
up by
Which
the?
part of
Is it
image
raised
you
up by
look
the
through
same
as
amount
to
in
how
our
much
field of
it's
view?
raised up?
Is this bit raised up the same as this bit?
Oh no,
I don't
it
know,
just
I'm not
happens
seeing
to
your
match
image
the
at the moment.
curvature of the Earth, Nathan.
Most likely. I mean, unless the atmosphere is changing that much over that distance.
Well, that's the problem. As we look from
Well, what about the atmosphere at
as
home?
we look from right to left, we are looking further and further over the curve of the Earth.
Yes, you are, and a further
Why
and
couldn't we
further
see that as
distance
well?
means that the light is bent further.
So you're saying
Which
that it
part
just
of that
happens
don't you
to
get?
it just happens to bend further and further as we go further along the image. So can you evidence any evidence of that change?
Most certainly.
Can you
Go on,
show
then.
me? Where?
Whole
In the image.
is being raised up, Nathan.
Yeah, but
The
hang on.
whole image is being raised up.
Including the
Asking
stuff we
where
have
it
direct
starts
line of
and
sight
stops
with.
is a non-question.
So it's all being
we know
raised
the
up,
effects of refraction
and it's
are
all being
negligible.
raised up perfectly along the curve of the Earth, along the whole length of the image. Is that correct?
That's correct.
Right.
It's raised
How
up.
do
The
you
whole
figure out
image
these
is
Paul-
raised
a
up.
lot of things
The
they
whole
can't
image
prove?
is raised
Ah.
up. How hard is it to understand?
Do you agree that the effects of refraction are by definition negligible?
They are not negligible.
Why don't you?
To account, then you
Absolutely
certainly
not.
can't say they're not they're negligible. You can't
Well,
take, you
that's
can't
what
say
the science
something
tells us.
that you have to take into
That
account is
paper
negligible,
is
Anthony.
making
Come
the
on, I
assumption
mean,
that the
Your science
distance
tells us the effects of
is very
refraction are
close.
negligible.
No, bullshit, Anthony.
not
you
worth
don't
In
understand
that
science.
paper,
That's
Science
close.
actually tells us that it's not negligible over bodies of water.
Negligible.
negligible over large distances.
and it certainly isn't if you have
I
to
have
account
a
for it.
simulation which
Certainly
shows this. Do you want
negligible
me to
over
present it
bodies
to
of
you?
water.
It says negligible, Paul.
It says negligible under standard refraction conditions. This is not standard.
It's the Emperor's
Looking
New Clothes.
35.1
We have to believe
miles
all of this
over a large
nonsense
body
just
of
to
water
believe that we
is
see
not
something.
standard, Anthony.
Paul,
Which
Paul,
part
Paul,
not standard don't
Paul,
you
what's
get,
standard
Anthony?
refraction?
Can we have-
We have to believe so much nonsense to believe there's that wall in the way, Paul. The amount of nonsense we have to swallow. To believe that there's an obstruction blocking our view, we have to swallow
Could
such
we
a
have a
huge mountain of nonsense.
Could we have a look at the turning torso by Mathis KP? And we'll see what an
It's variable. My wife's asking how much is it
Earth
refracted
looks
by,
like.
and I'm explaining that it's variable as we go down the coast. You can't see any of these variable refraction
would you like
layers.
To see,
It's really
would you like to see what Earth curve looks like? A
It
wall
has
of
to be
Earth.
variable because they live on a globe according to them.
Yeah.
Right, if you're sharing my screen, you could see refraction over ice and water. Okay, refraction over water. The last bit of this paragraph down here says that Kobayashi in 2003 obtained refraction coefficients from +1 to +18
It's still
from
negligible, Paul.
reciprocal vertical angle
That's
measurements.
not negligible.
Line of
What does
sight
Anthony? What does
over
what's a refraction
Plus
coefficient of +18? Now you have time to read the paper.
Yeah,
Can you
but
tell me?
what's plus 18 what? Plus 18 what?
It's still
plus
negligible.
18
Refraction
means
co-
that
It's not
No,
negligible.
plus
Right.
18. Well, wait a minute.
It
Chris,
means
you
it's
might
not
know.
negligible.
Let Paul.
Well, Ali,
let Paul
I asked.
plus 18.
I-
A
What?
standard,
Let's
a
say, hang on,
standard
Paul.
refraction coefficient is 0.13.
Paul, let's just
Right,
say,
what's
Plus 18 is extreme.
Paul, let's just say that you're right with your numbers
Standard
here.
refraction for air
Were
is
we over ice?
1.000295.
Was we over ice, Paul?
It was over water, Anthony.
No, were we over ice when we took the evidence?
Anthony, you knocked these guys out about 30
Anthony,
minutes ago.
Anthony, why
How's
are
it
you
relevant?
strawmanning? The sentence I picked out said over water.
It said over ice.
Anthony,
It said over
we
No,
asked
over
Anthony a question
water.
earlier.
And
I'd
water.
like to follow
Over
up.
water. Which bit? There. Over water. Do I need to spell it? OVERWATER.
Anthony.
Over water.
Paul.
Anthony,
Comparing it over
remember
ice
I asked you,
over water.
Nothing. Why don't you go?
Anthony,
It's embarrassing.
remember when I asked you
Why
what,
don't you go away? I don't want you coming
Ali.
here for.
Yeah,
Ali,
you're
just
coming
I
to
want
laugh at
to-
people like you, Ali.
want to
Ah,
ask,
but you're just interrupting people.
Yeah, I
for
don't care.
laughing.
I wanted to do a
Okay.
follow-up question.
Go away. Go away.
Anthony, now you've had time
So I
to read
guess,
this
Anthony, what
article.
you need to do is you need to know the conditions over the water.
No, we don't, Paul. We just apply
You
7.6
do.
R and it
Why?
gives us the
How
answer.
can you calculate the refraction if you don't know the conditions over the water, Anthony?
Because we're told 7.6 R, Paul. It's straightforward.
Yeah, we're told 7.6R under standard
standard
atmospheric conditions.
refraction.
This is not standard.
But you can't prove it's not standard, Paul, because there's
How
no evidence to
stupid are
support
you,
your claim.
Anthony? This is not
There's no
Anthony.
evidence
standard.
to support your claim. though,
Over
Paul.
What is
water.
a-
Over
what is a
water
refraction?
is not standard, Anthony.
Paul, you're comparing it to ice over water, and obviously there was no.
No, I'm comparing over water. This
No,
bit
but the
here that I've
article
highlighted says
from
over
ice
water.
to water. We're not looking at ice.
No,
Paul. We're
This
looking
is
at
not,
water.
no, it does not say ice to water. This
Read
is
what it
over
says, Paul.
ice and water, Anthony.
Yeah, it's comparing it to ice and water, but we're only in water, so that's not going to give you extreme
That's
refraction,
right,
is
and
it,
that's why
Paul?
this last
Have you
sentence
read your
refers
own
to water,
source?
Anthony,
Obviously
not
not.
to ice.
Paul, your own source is
The
basing it
last
from.
sentence,
Paul, your own source
the
is
last
comparing
sentence,
ice to
Anthony,
water.
says Kabashi 2003 obtained refraction coefficients from +1 to +18 from reciprocal vertical angle for a line of sight about 5 meters over water.
Yeah.
Where does
Anthony,
it
can you tell me
mention
that
anywhere
means?
in that sentence about ice, Anthony?
Paul,
Can you
where's
show
the
us the
comparison?
images?
Now you've had time to read that article. Can you tell me what refraction coefficients of +1 to +18 means?
And can we
Wait,
see the
Last
images?
year, Ellen, you said
Can we
you
see
had
the
to read the
images?
article.
Can we see any
Paper
images
up
to actually get an
justify
idea of what
already
that looks
asked you,
like?
you said-
Okay.
Can we see what that
actually,
looks like?
yeah,
Any chance of us
this
seeing
morning.
what that looks like as opposed to just hearing about it on
Point
paper?
I'm trying to make that it only needs a refraction coefficient of +2
Right,
to
but
account
Paul,
for the
do you
big.
not see that you are comparing ice to water in your paper?
No, that is not true. You have a comprehension problem, Anthony.
It says right there.
Just a bit.
Read what it
Do you
says,
have
Paul.
difficulty understanding what the English language is about?
Read what it says, Paul.
Paul,
What does it say, Anthony?
I have a recommendation for everyone who is normal and understands things properly. Leave these people alone. They don't care. Your attention is what they want, and they will do anything to keep it.
Yeah, but we didn't invite the ball earthers in, mate, so we've just got to put up with them. So, unfortunately.
Well, it wouldn't be a fly up debate without us.
Oh, Lewis didn't want to get knocked out today. That's why he got out of here real quick.
No,
So you're trying
Dave,
to say
David, this place is
it's
at
always standard refraction when it's not.
y'all lose if you lined up the
Clearly
buoys
isn't.
across.
What's standard
clearly
refraction then,
can't
Paul?
Yeah, Nathan, Paul, what is standard refraction?
refers-
Just as a
Okay, let's
comparison.
see. Right,
just
standard
goes
refraction.
I
Let,
should be able to
Hello,
tell
guys.
us. This is this.
let me get up the actual things for standard refraction.
Right, so
I've
yeah,
got it along
right,
here
okay, so
somewhere.
you don't know.
I do know
No, you
what
don't. I
standard
thought you were a
refraction is.
physicist. You should have all this off. You should know what standard
That's an
refraction
on the
is.
spot
I
fallacy.
do.
That's
I do.
David
I
said he
man.
does know. So
Chris,
What, so I
Chris,
can't
you
give
know
an answer
nothing.
in
You
2
don't even know what
seconds,
you're
so I
talking
mustn't
about,
be
so keep
true?
quiet at the moment.
What a
I'm
load of
speaking to
garbage.
Yeah. It's going to show
Standard
you that. and you have
refraction
to apologise.
refers to standard atmospheric pressure under a standard temperature of around about 20 degrees Celsius under a temperature gradient of 0.0065 degrees Celsius decreasing per meter with altitude. That's what standard refraction is.
All right, okay, now,
This is not
does
standard
water,
refraction.
does light refract more through water, or does it refract more through air?
It reflects.
Well,
it
we're not
refracts
talking
over
about
dense
through water. We're
materials.
not trying to look through water, are we?
Well, is it humidity, water vapor? Does light refract more through water vapor or just normal air? Dry air.
It refracts more.
What,
It
through
refracts
water?
more.
What, through water?
We're not talking about looking through water here.
Water. Is that what you're saying?
It refracts more through water, yes.
Oh, does it? Okay.
It does,
And
yes.
how is this related to anything that we're talking about?
Well, because a humidity,
How
my
this is
friend.
related is
Humidity,
because as the
humidity,
refraction-
humidity.
Okay, so
Can I
humidity
talk?
makes the refraction
As-
large.
It makes it
As
less.
the refracting,
It makes it
as
less.
the refraction. Oh,
It
shut
refracts
up!
less
As the
than it
refraction,
does.
as the refraction coefficient increases, the
refracts
refraction
less.
increases.
It refracts less
So
through humidity.
Water refracts
through water
light
vapor.
more, but when there's water in the atmosphere, it refracts less.
It refracts less. Yes, absolutely.
Right, Paul, can I come back?
Okay,
to
I don't quite understand the
points
physics
based
of
on your
that. But
paper?
Well, it's your physics.
Hey, Channel Q,
I,
good to
I
have you
don't. I
here.
don't know where that's going.
Say a quick hello. Hold on, guys. Guys, got a new guest. Bear with us.
Paul?
Hi, Channel Q.
Would
How
you
you
like
doing?
to see
It doesn't.
vapor?
Bear with me,
The
guys. I
material's
don't.
more
Oh,
dense, so it should refract more.
I was hoping to
But,
get to an
I
hour
don't know
without
if
having to turn you all down. Right, can I say hello to Channel Q? How you doing, Channel Q? Good to have you.
Hi, Nathan. I
Good
just
to
want to
see
say
you.
for the record, yeah, I was mad because you ejected me, and the only reason I muted Allie was because he was talking over you, and you were asking him to stop talking, so I just muted him so we could move on. And then you ejected me for that, and you didn't even tell me why. And then I was mad, so I said I unsubbed, but obviously I'm still.
I'm glad the
Yeah,
girl
yeah,
off the chest.
that's a
Anyway,
really good
been joined by
response.
Jedi. I know he's been booted already.
Oh, hello, Nathan, as well.
Hello, Dawn Treader. Good to have you.
Paul, can I just get back to you about two questions about
And we've
your-
also been joined by Soundly. Good to have you here, Soundly.
Yes, Soundly.
Oh, it's sound.
CGI
Dun,
bird,
dun,
Soundly.
dun.
CGI
There
birds.
you go.
Why did you put those birds in there, Soundly? I mean, come on. NASA, you should know better. A good wage from NASA.
All right, so can we get back to this? What we were talking about before?
Hang on,
No,
Soundly's not done a mic check yet.
Let's not go back to that, please.
Yeah, exactly.
Yeah, I said hello.
Paul, can I ask you two questions on your refraction paper that you cited?
Oh, you can.
The paragraph, I think I'm right in saying, was 2.33, refraction over water and ice, right? My first question is, if you compare ice, the refraction index over ice over water, and you get the claims that are in here, which one would you claim is the standard refraction over the other one being non-standard refraction?
Neither. Both are non-standard. Both are non-standard. Both over water and over ice would be non-standard, Anthony.
How would you
part
know
of that? Don't you understand?
How would you know that they're both non-standard?
Both are non-standard because the refraction coefficients are between 1 and 18. They are both non-standard. A standard refraction coefficient, Anthony, is 0.17.
But do you realise that the effects of refraction are negligible?
Only under standard conditions. These are non-standard conditions. Which part don't you understand, Anthony?
Well, the bit where there's no evidence to support
They're
this.
negligible under standard conditions. These are non-standard conditions,
But you haven't
Anthony.
got any
Do you
evidence to
have
make that
your
assertion.
cognitive dissonance?
It's like this, Anthony. It's just like this.
You
It's
don't
like
have
the
any
normal
evidence to prove
temperature of a
it's
human being is
non-standard,
98.6 degrees. That's the standard. If you have a fever, then you have 104-degree temperature. That's a
Yeah, fine, but
non-standard.
you would have evidence
That's the
of the
same
fever.
thing that Paul is trying to get you to understand about
I
what
understand,
is the
but if
difference
you had a
between
fever, you would know
standard
because you would have a
refraction
thermometer
and
that told you.
non-standard
My
refraction.
question is, what
It's the
evidence has
same
Paul
thing
got that
when
this
you
is
have a
non-standard
fever,
refraction?
it would be non-standard
Because it's taken
temperature,
over
body
a
temperature.
large body of water, Anthony.
Well, that's
Any
not the
measurements
evidence.
taken over
water-
ice
right there.
will be
Water is
non-standard.
going to create a different kind of standard for refraction than
So
normally.
you've cited evidence that ice over water is different, but you haven't cited evidence that water over non-water body, non-water.
So what is
It says
this?
right there,
What does
Anthony,
this
over
say
ice and
in
water.
that
Yeah.
section?
Well,
What does it say
Coefficients
about
from
water?
+1 to
So given that-
+18.
If he's saying that
Given-
both of these are non-standard, shouldn't he be citing the evidence that shows the difference between water as non-standard over land that is standard?
So
No, it's
standard
not.
refraction is defined.
He's done you
in
too much.
times do we have
He's
to
indulged you way too much
You have
already.
to say it enough so that we can decide whether this is non-standard or standard, Paul.
Right, I'm
Because you
going to say a
haven't
quick
shown how
hello.
we can
Sorry,
work it out.
Anthony. I'm just going to say a very quick
But the
hello.
fact that it is
Sorry,
over water
Q,
makes
bear with
it
me. Just want to say I've been waiting for a
That's
while.
the point.
Bear with me. Just
He
want to
hasn't
say
produced
hello.
evidence to
Hold
prove
on,
that.
hold on.
Paul is trying to give you that evidence. If you
Bear
decide
with me,
to.
guys. I just want to say hello to Curved Water. How you doing, Curved?
Hey, man.
Hey up.
Good to have you. Thank you.
Nope.
I'm good. Coming in good.
Yeah, fine. Good today.
Very good. I'm important. I need to be heard. That's good. Thank you.
You are important, Curved. You are.
Now I'm going on mute.
So, Paul, evidence proving that water observations are non-standard refraction, please, because I don't see.
Well,
any
there it
evidence.
is highlighted in blue for you, Anthony. All you
Where-
need to do is read.
All right. So,
So what
where's
does
it?
it say?
Show me. I can
Anthony,
see
read it.
Read it.
Could
But
you
where
read that
does-
sentence
Read
for
it
us?
out loud, Anthony, for us.
What does the sentence say, Anthony?
The bit highlighted in blue.
Yes.
Yes.
Refraction over ice and water.
No, that's not what's in blue.
That's what it says.
Come
I don't
on,
think that's what it
man.
No.
Where's the bit in blue? Am I not seeing something that you can see?
No,
The
there's-
last
not
sentence.
No, you got to pick on the
Final
first thing.
sentence.
You got to pick on Paul's screen.
So this one, the Kabashi one, yeah.
Yes.
Yeah.
Right.
What
Okay,
does it
so-
read?
All right. So Kabashi obtained refraction coefficients from +1 to +18 from reciprocal vertical angles for a line of sight about 5 meters over water. However, my question
Over
is,
water.
how
Okay,
does this?
that's
Where's
it.
the evidence that
Over water.
proves that this is non-standard refraction? Because it could be either.
It's in that paper. Why don't you
Because
go read that
standard
paper?
refraction because standard refraction, Anthony, has a refraction coefficient of 0.17.
Right. Can you prove that, please?
Do you think that? Well, yes,
It's
I
in
can.
the paper.
Yes,
Yeah,
but you
would you
won't
like me
accept
to
it.
actually do
Prove
the
it.
calculation for you?
0.17. Did you say?
Yes,
So
0.17, Anthony.
Reciprocal.
Anthony, what does
vertical
refraction coefficient
angles.
from +1 to +18 mean?
I'm looking for the point where it says
Non-standard.
anything above 0.17
But I asked-
is considered non-standard.
That's what it's
I
defined
asked you this
as.
morning, and you
That's
said
right.
you needed
Okay.
context. So now I'm asking, what does it mean?
You're asking what?
I asked you this morning, what does a refraction coefficient from +1 to +18 mean?
It means that there is a minuscule,
means.
unobservable, unmeasurable level of refraction.
No, it's
Absolute
in fact,
garbage.
in fact, it means
What
it
it
is
means- what it
measured.
Well, I finally got an answer.
Aye, you've got an answer, and it's completely and utterly in line with normal refraction standard.
No, it's
refraction.
completely and
No.
utterly wrong.
So, Paul, show us where does it say in
Absolutely.
the article that
Yeah.
anything above 0.17 is considered non-standard refraction, please?
How about if Anthony
Well,
backs up
would
what
you-
he just said?
Yeah, exactly.
Well, I can back up what I've just said, no problem. But in the meantime,
Go
I'm
on.
going to come back to curved. I'm going to ask. There you go. Under standard circumstances, the effects are negligible. What I'm asking you is to show us where
These
is-
are not standard
right.
conditions,
So I'm asking you,
Anthony.
Paul, I'm asking you to show us where the divide is. Where is the divide between standard and non-standard? Where's the evidence to show?
Anything above 0.17.
Yeah, anything on
Not
land would be
standard.
considered
Anything that
standard.
is not
anything underwater would be
0.17, that's what
considered non-
non-standard means.
Evidence, please.
That's
That's
it's not the
That's
number.
the running-
he's just running us
Therefore,
around
it
in a
is
circle.
non-standard.
Yeah, that's all he's
How
doing.
is that?
running
How is that any
Shows that
more clear?
refraction is beyond 0.17 is non-standard.
Anyway, Anthony,
That's correct.
Anthony, you're just simply wrong. The coefficient of
evidence
standard
to prove that
refraction
I'm
is 0. We don't need evidence. It's a definition.
You're,
Yeah, you do
you're
need
not even following regular logic.
0.17 is the definition of standard refraction. So if you measure something different, it's not standard refraction. That
Right,
is
so
by
where's the
definition.
evidence that says that standard refraction is
There
0.17,
isn't-
please? It's straightforward
the-
request. It should
the
tip
evi-
of your tongues.
It's
The evidence is
determined
the evidence is taken.
from
The
this-
evidence is taken as a
as a collection of observations made over land. This is what they have measured in reciprocal angles.
All right.
Let
me read.
Reciprocal vertical angles. They have measured this to be the refraction that they measure over land, over and over and over and over and over again.
Where's the evidence that shows that
this has been done?
Standard refraction,
Anthony,
please.
let me remind you that Paul has done this calculation here.
Yes, I want to see the proof. I want to know where the line is drawn. Prove it.
He got
There
it.
isn't a line. There isn't a line. It's a gradient. It's a range.
Let me counter you, Paul. I'm calling BS, and I'm gonna say now, and you can prove me wrong because you won't prove your own position. So I'm gonna make you a position, and you can show that I'm wrong. That might be easy for us. Standard refraction at 1 atmospheric pressure is 1.000293.
That's bullshit. That's your refractive index. That's not the refraction coefficient.
So show that
it just shows how little you understand, Anthony.
Show that
it
the
shows how
refraction
little you
coefficient
understand.
at 0.17 is non-standard once breached, please. You can't show that, Paul. Stand down.
He doesn't have to show it.
Of course he doesn't.
Because it's a definition.
There's two ways of measuring it.
He doesn't have to show it because it's a definition. You keep asking for proof of a definition. That's like saying prove that the definition of blue means blue.
Right. It doesn't say in the evidence he cited where the divide between standard refraction is over non-standard. He's saying it's 0.17.
What difference would it make, Anthony?
If you're standing facing the water, then that's where the non-standard is. And if you turn around and face the land, that's where the standard is. The divide is you.
Show me where the divide is, and Paul is
You are the divide.
Version. I want to see what it says. On 0.17, we consider
You are the living divide.
If you can't prove it, Paul, you're talking BS.
Sorry, can I just get some clarity from
your case?
From Channel Q? So what Channel Q is saying is that standard refraction is over land and non-standard refraction is over water. Is that correct, Channel Q?
That's my gist of it, yeah.
So do you have a citation that backs that up and asserts that as well? Oh, Paul's already...
standard temperature and atmosphere, I would say.
Standard pressure,
Do you recognize
temperature.
this page, Anthony? Do you recognize this page? How many times have you taken us to this wiki page on the International Standard Atmosphere?
Loads.
That you went to, and because you could not find 7.6 radius on here, you cried and ran away from it.
No. I said no. You see,
yes.
You do this intentionally.
Yes.
I didn't run.
You couldn't find 7.6 radius on.
You've already said that, Curved.
Right.
My position. That is not my position. What I said was there is no mention of the radius in the proper calculations.
Right.
So why is it based on 7.6R? That's what I said.
Because that is derived from Fermat's principle under the assumption that you have standard atmospheric conditions.
No, it isn't.
It is.
No, it isn't.
It is.
Yes,
It's based on an apparent radius, and it's
No. You have to integrate the equations of motion for the light, solve the boundary conditions, and you will find that the light ray bends.
Right. Look. Let's see what it says. Sorry, I need to share my screen. Nathan, can you present me so I stay on? It says with standard refraction 7.6R. Okay, that's an arc geometric calculation. Okay, and when you click into the
what do you mean by arc geometric?
Geometry 7.6R. It's an arc.
Oh my God.
7.6R is not an arc.
Look, what does that say there? Somebody read that because I'm stupid.
7.6 radius is not an arc.
I see where the disconnect is happening here, Anthony.
Well, hang on. Let me read it, though. Let me read it, because obviously nobody's done it.
He doesn't understand the mathematical formula.
The value of 7.6R is a rough approximation of the effect of refraction on the apparent radius of the Earth. The apparent radius.
Because the light rays bend in this atmospheric conditions.
Right, so it's an apparent radius. That's the first point. The second point is 7.6R always goes down. It never goes up.
Because the index of refraction goes down as you move away from the surface of the Earth.
Right.
Because understand
I agree.
So that means that
the
the
refraction
ray
coefficient
is going to
0.17, which means it goes to
right. So why is it when Soundly shows these eight lamps on 8 poles, he shows light bending up? How is that calculated?
Because it's non-standard.
Because it's not
Why
standard.
can't you understand, Anthony? It is non-standard.
Right, so where is it in the maths then that non-standard calculations allows light to bend up? Because it's all talking about a radius. Paul.
Because the index of refraction increases as you go up, not decreases.
Because the temperature gradient is the other way. Because this formula that calculates the refraction coefficient, Anthony, allows for you to add or subtract the temperature gradient.
Yeah, but it still goes down.
Which allows for a refraction coefficient to be positive or negative, Anthony.
It still
which means
goes
that
down,
light
though,
can bend
Paul.
up or down.
It still
It
goes
doesn't
down, and
matter.
it's based on a
Depends on
radius.
what the temperature
It's not
gradient is,
proven.
Anthony.
It's not based
You
on
are
a radius.
showing your ignorance of the mathematics,
If
Anthony.
anything curves, it has a radius of curvature, right? That's all we're saying.
That's right.
All right, now what happens if the radius that you calculate after you put in all those numbers into the equations and formulas, and then you come up with that thing that gives 7.6 radius for standard conditions? What happens when that gives a value that's less than 1? Let's say it's 5.6.
So we're coming up on approximately 1 hour left on this broadcast. I hope you've all enjoyed the debates thus far. Please share the show. It's been an epic event thus far. So if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside each of these live shows, and if you would like to join the debate with the page you are currently watching on mute, simply click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. There are a couple of rules in the Hangout. Number 1, please do not swear. If you do, you'll be ejected. And if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Once again, if you've not done so already, please share the stream. And if you've not subscribed, hit the subscribe button and the bell notification icon to keep up to date with the Flat Earth debate.
Show you. I'll actually show you. What?
Nathan was talking over all of us.
We've got a new guest, I think. Who's this? Who's Effie? Hi, Effie.
Hi,
Effie,
Nathan.
New England.
It's me, Jibby. My other account got
Hey.
sniped and blocked, so I gotta use another one.
Good to have you. Nice to see you.
Carry on. I was just enjoying it.
That's a good look at that.
For those
your explanation of this.
For those that are actually interested in where the calculation for standard refraction comes from, if you share my screen, I can actually show you where this 7.6 sonar actually comes from. All right? So what you'll see if you share my screen, what you will see is the actual standard values for the lapse rate of 0.0065 degrees Kelvin per meter, decreasing as we go up. Okay? And the temperature at 288 degrees Kelvin. If we plug those things into that formula, which was 503 times the pressure divided by the temperature squared, multiplied by this thing here, here's the lapse rate in, and when I press equals, I get a value of 0.17. Now, if I do a calculation of 1 divided by 6, I also get a value that's very close to 0.17. That's where the 7 on 6 times R comes from, because 7 on 6 is 1 plus 1/6, right? So 1/6 is 1.16. That is what standard refraction is. I've just showed you that we plug in the standard values for the lapse rate and for the temperature of the atmosphere and standard pressure of 1013 millibars, and we get the standard refraction coefficient out. If I plug in other values, I get non-standard refraction coefficient.
Can you show us some visual examples
So-
of both of those then, Paul?
What's that?
Some visual
Do you want me to do a
examples.
calculation where it's
No, you did.
non-standard
You.
refraction?
I said visual
mean
example,
showing
and
the
you
bend
heard
light?
calculation.
Bend
It's exceptional how you can do that with your hearing. So, can you show some visual examples?
I actually did the
I have
simulation
some
of the
examples
lights.
of some lamps hung on pylons if you want to see those.
Oh, okay. Yeah, actual pictures will be better.
Yeah, Paul, can you show us some visual examples of refraction, like non-standard
Soundly's
and?
going to do it.
Sorry.
Well,
Seems
it's
to have gone
it's
very,
just-
very
it's just
quiet.
that time lapse. It's just that time lapse that I did that Anthony Riley keeps working over and over again. If you want to pull it up, Paul, go ahead.
Yeah, I can pull it up if you like. Let me just go to it. I've stopped sharing at the moment, but I can pull it up. Let me just go to it. I have to. I've just got to get to it. It'll take me a moment. Got so much stuff here. Okay, go to videos. Now I've just got to find it.
I'm just reading the comments here.
It's all right. Soundly's got so much stuff here that I've just got to find which one it is. Do you know what it's called?
Oh,
Again, Soundly.
Yeah, let me find it for you. That'd be easier. Let's see.
Yeah, I've got it. I've got the time lapse. Okay, so I will share. Okay, it's being shared on mine now. Let me skip the ad.
It's towards the end.
Can you make it full screen? Thank you. That's brilliant.
I can.
Hi, Jay Badger
Towards the end.
and Near Base, by the way. Good to have you both here. Hi, P. Miles as well. Good to see you.
Panel anymore. Somebody keeps sniping me, and I'm not going to be able to join your panel anymore.
I've added you on Skype, Jibby, so if you want to join via Skype, if you get sniped again, just join the call.
It keeps saying that I'm blocked because
I've been sniped already.
I think I've gone too far, haven't I?
It's a disgrace, that.
No, it's in the dark. It's in the dark. Go to the dark area. With the night shots. It's in the night shots, and it's pretty close to the end. There you go. There you go. There you go. There you go. Right there.
Wow.
Okay, so you can see that it's bending up at this point here.
Yeah.
Okay, so that's non.
So is this
refraction, and guess
really,
where we're
really neat.
over water.
And just to point out, there's two lights that are kind of like offset from each other on the left side. It's the
Can you
left side
tell
of the
which
frame.
changed, Anthony?
Those two lights are on land, and they are also moving up and down due to refraction. So the whole land down there, the whole boat
Paul?
is moving up and
Sorry.
down.
Yeah, that's.
Well, you can see the
Paul?
see the causeway up above it. Moving too.
Paul, let me ask you, Paul, is this standard or non-standard refraction?
Well, non-standard.
How do you know?
I'd also
How do
like
you
to
know?
point out, just as a side note here, that the lamps are being reflected in the water. And if the water was a perfectly flat surface, then the reflection should be perfect. It should be an exact reflection of the lamps, which it is not.
Paul, how do you know if it's non-standard or standard refraction, please?
God.
Oh, Anthony, for God's sake.
Seriously, how do you know, Paul? How can you tell?
We know it's non-standard because it's bending up, Anthony.
So it's non-standard when it bends
Which
up,
part?
and it's non-standard when it appears flat. But when it bends the way that you want it to, it becomes standard, does it?
Anthony,
It's actually
when
very
standard
rare that
is-
it's actually standard.
Jesus.
It's very
So
rare
again,
that
I
it's
asked the question, Paul, where is the evidence to draw the line? How can we tell when it becomes non-standard, please? Where is that evidence?
What do you
Where's your
mean
maths,
draw the
Paul?
It
line?
becomes non-standard. I'll just say it over and over again. It becomes
Why don't you
non-standard.
understand what the
when
word
refraction
standard?
I know what
Standard
you
is
said,
like
Paul.
regular.
Non-standard.
I
So
know
when
what
it's
you've said, Paul. I'm
irregular,
asking you
it
for the
becomes
evidence.
non-standard.
I'm not asking you for
So
your
what you're
opinion.
used to
I'm
seeing
not asking you for your.
changes. All of a
I'm
sudden,
asking
it's
you
not
to
the
prove
standard
what
anymore.
you're saying is true.
Anthony, understand when something changes that they can't give you every single example for conditions.
How
so
do we
they
know?
give you a standard.
How do we know the difference
model,
between standard and non-standard refraction,
conditions
please?
to tell
Where
you
is the evidence to tell
to
us?
go off of, and then you can work off of them.
So Anthony, standard is defined for standard atmospheric conditions, and
Yeah.
anything which is not standard atmospheric conditions is not standard refraction.
Right, can I see that evidence, please?
It really is.
Wherever
that
it is
simple.
you've just
Literally,
read
that's
that,
the
can you show it?
definition. If something
You've
is a
looked at it,
standard,
trust
then
it,
it is a
Andy.
standard. I mean,
How many
I don't
times
know.
have you looked at that page, Riley?
Right, but I'm
International
asking
No,
where
no,
the
no,
line is
standard.
drawn so that we can work it
What is
out,
a
because we're
standard
thick,
pound,
flat earthers,
right? Like a
and we
pound
can't
is
tell
a
the
standard
difference between
refraction.
standard refraction
Anything
and
that's not a
non-standard
pound is
refraction.
not
So I want to
standard.
see the difference so I can apply it and then go, oh, right, now I get it. That's non-standard refraction. So where's the
How are
evidence
you
for
gonna
me to
apply
draw
it?
the line?
Ton of lead or a ton of feathers?
So the only way you can
Yeah.
tell if it's not standard is if you measure the atmospheric conditions. I mean,
Surely you can judge it by how much you're seeing as well, according to the.
Yeah, but that's what I'm asking.
Well,
I'm asking, how do we know? Because Paul seems to know exactly when it becomes non-standard. It seems to become non-standard the minute it starts to look flat. I'm calling BS. So I'd like to know what the evidence is
Let me
that flicks the
let me
switch for
point
Paul.
something out here, and that is, if you have objects that are off in the distance, right, way past the horizon, then whenever that type of non-standard refraction kicks in, those things will be pulled up to where you can see them past the horizon, right? But if
Right,
you
but
have
how do we know
objects
it
that
becomes
are very
non-standard? That's
near,
what I'm
if you
asking.
have objects that are very near the horizon, the actual horizon and that object that is being obstructed by the horizon will all be lifted at the same time.
Right, but I'm asking,
So
how
the
can we prove
obstruction,
or
the
know?
obstruction, even though it pulls things up and makes them look straight, the obstruction height for an object that's very near the horizon will not change because it's being that
Right.
whole piece right there is being
Soundly,
affected
I
by
believe
that-
you, but
by
I'm
that
asking for
refraction.
what is the evidence
That's
that
what-
shows
that's
us
actually what you see
where we can
in
learn
those
that from.
time
the only way you can really convince yourself of this, Anthony, is if you do multiple measurements, and you'll see
Right,
that your
so therefore,
measurements
Paul
will
without
change
measurements
over
can't prove that it's non-standard, can he? Ding ding.
No,
Andy,
you
what
math
difference
proves
would
it
it
all.
make to your image? You've not even. Are you planning on going back? You've not even gave us a GPS reading of the altitude you're at.
This is childish.
You can have up to 100 feet, no
You're
problem.
going to win that award, Anthony, I
What
think.
difference does it make? You can have 100
This
feet, no
is
problem. What
infantile,
difference
man.
does it
I'm
make?
sick of this.
So Anthony,
Really.
I mean, to be perfectly honest, like this, you have to make multiple observations in order to prove your theories. So I mean, like this
That's a-
one
that's a fair
observation is
comment.
great, but you have to
That's
do
a
it
fair
over and
comment.
over and over again. It has to be repeatable in order for it to actually be a real
Very
theory.
good point.
What is your mum going to
I
say
agree.
when you win
I
that
agree,
award?
Philip. And do you know what I'm going to do just for you ballers that think that in some way I magicked it up? I'm going to go back in the beginning of January, early on, because I'm really quiet in work then, and I've got oodles of time. So I'll go back in January
Alright,
just
do
to
it.
see
Honestly,
what I can
like,
get.
that-
And do you know
that's
what
actually
will
really
happen when I come
interesting. I
back?
hope you do
You'll
it.
still
Take a
dismiss it.
GPS reading this
So
time.
again,
Yes,
we come back
yes,
to
you should take
how
your
can
bearings so that we can settle this Ireland issue,
Fine, yeah,
right?
sure, that's fine.
use a
That's fine.
compass.
However, let me
Do
ask
it.
you guys this. I still want to know how we can distinguish between standard and non-standard refraction.
Oh my
because Paul's
God.
got no evidence to
So
prove
measure the
one or
temperature.
other.
If the temperature is
But he
not
cites it.
at
Andy, what's the
whatever,
standard
200
body
and something
temperature of a human
degrees
being?
Kelvin, then
I will tell
it's
you what
not
Jesse-
standard.
Okay,
Okay,
I'm not
What's the-
speaking. I'm not speaking as an expert. I'm speaking as someone who has watched Jesse work and him explain to me. So it'd be good to have Jesse on. But Jesse says you take reverse reciprocal vertical. What's it called? Reciprocal vertical. What's the word I'm looking for? What was in that definition?
Reverse reciprocal vertical. Wow.
It's
Are
reciprocal
you talk-
vertical.
I don't know. It's
What is it? It's in that definition.
The K,
Paul.
the
Pull it
K
up.
thing.
Yeah,
Are you talking about the
scroll down to it
continuous
again.
variable
But
simultaneously solving the vertical
vertical
pressure
angles.
variation?
Yes, reciprocal vertical angles. Basically, you go to both ends of your observation and you measure the deviation from 90 degrees that each of
Right.
those ends have, and you do that
And
over
do
and
you know
over and
what,
over
Sound?
again,
Yeah,
and you
I'm
come
with
up
you.
with an average.
I
and you
agree
figure-
with you.
and that's how they figure
I
out.
agree with this only. But my question is, how does Paul know without that evidence that this is non-standard refraction, or has he plucked it from thin air?
No, I haven't plucked it from thin air at all. The very
So what
fact
evidence
that
have you
we
based
can
it on then?
see the light.
What?
Are you going to interrupt, or
evidence
are you
have
going
you
to
based
actually
it on,
let me
Paul?
answer your question, Anthony? All right. The reason
Triggered.
why I know that it's non-standard refraction is because under standard refraction conditions, the lighthouse should be hidden. The very fact that we see it indicates to us that it's non-standard refraction. Anthony.
But it doesn't prove it though, does it, Paul? That's the point. You can't
It
work it out
does.
because you don't have the values to be able to do the sum that tells you whether it's non-standard or not. That's what I was getting to. So how can you assert that it's non-standard without being able to prove it? Have you just plucked it from thin air, Paul?
I put in the other day into the calculation the values from that day. I looked up the sea temperature
don't know
was
the
10
values
degrees
from that day,
Celsius.
Paul, 'cause
I
you
looked
weren't
up
there.
the air temperature was 13 degrees Celsius. We estimated a atmospheric pressure. I gave you standard atmospheric pressure even. I even gave you
How do you
only
know, Paul?
1
You're plucking
degree
it from thin air,
Celsius
you're
temperature
guessing.
gradient per 20 meters.
So it's okay
Just
to
on
guess
nuclear
that.
water, it's much larger than that.
The temperature of your the ambient temperature and the
you've guessed
pressure.
it, Paul.
Guessed it.
You've guessed.
So with
Had a little guess.
you were
You
able to
didn't know
show
the
that you
figures,
could
Paul, so
actually
you
see the
guessed it
lighthouse.
and then claimed it was non-standard because of your guess.
Yes.
Sounds really honest, that, Paul.
Okay.
Yes.
So
We'll
if
guess the
there's a
height,
range of
we'll guess the
parameters which
pressure,
are
we'll guess a whole
reasonable-
bunch of things till
How,
we get
how
it to
high
be a
was that
globe.
measurement what Brenda got again? Because you said the lighthouse was 231 feet. And that
Yeah.
measurement was 200 and some-
213.
13. So the lighthouse is what? 18 feet above the observer.
Is that what we see though?
I don't know.
No, we just see the
No,
lighthouse.
we saw the whole lighthouse and the rocks underneath it.
Okay, that's the refraction then.
You don't see all of the
Yeah,
rocks.
you say
see
that,
some
but
of
how
the
can it be
rocks.
proven?
That's right. And that's the point. You don't see all the way down to the ground. You only see
Well,
about
Paul would do.
25 feet of the cliff.
So
not
the-
all of it.
So one interesting thing is you can actually apply this the standard atmospheric model to the flat Earth, and you can actually kind of see what is going to happen in there. I mean, that's one thing we can possibly.
I'd like to see a model of a real horizon on a flat Earth, like how.
Yeah, exactly. With
blend effect.
All horizons on a flat Earth are real.
Oh, really? Is that why you can't zoom in past them?
Someone model a
can
flat
look.
Earth horizon.
Oh,
Like
how you
all
doing, Liz?
faded,
Good to have you.
faded, and that'd be sweet.
Didn't see you there, Lewis. Good to see you.
Yep, that's great. Good to see you too. Thanks so much. Now I'm here. Now we can get back on track. First of all, you threw out that was a guess observer height. It's not a guess. We used the photos of the places Anthony gave in his video, and you can use standard known lengths to add up things like the fence posts, and you can determine that the minimum cliff height that Anthony was standing on was 100 feet minimum.
No, Lewis, you're totally lying.
Yes, you can.
know
Lewis,
that value is miles
Nate,
wrong.
Nathan, did you read the comment?
Lewis, or you could use a map like I'm displaying right now with contours on it that show elevations, and it shows an elevation of 100 feet.
Yeah, and you know what, Paul? I'll give you the 100 feet, but you've got to accept that your model is wrong
What's
because your
interesting
model
is
only
when
puts
we,
it at
when we
50.
say that you were saying at 100 feet, suddenly what we see in the video makes sense for a globe perfectly. That's a little strange.
And
Yeah,
also,
sorry, do we ask this before? Sorry, can I just ask Paul a quick question, guys? Sorry to interrupt.
Before you jump on,
Sorry, guys,
I'd
just
like
need to
say
ask
that
Paul a
if-
quick
if
question.
your initial
Do we
point-
have the
if your
same
initial-
thing for
hold
the
on,
target?
Nathan, I wasn't done. I have
Do we
more
have
to
the same
say.
sort of map
Thank
for
you.
the target, Paul?
If your initial point, Nathan, was that Google Earth is not accurate, I would agree with that initial point, but there's not much of a discussion there. Like, Google Earth is not a topography map.
Sure, that's not what I asked.
Yeah, but
So
it is
does
your model.
Paul
Google
have a
Earth is
topography map for
incomplete.
the
It's not.
target?
It's not a model that is claiming to be 100% accurate. So you're trying to do calculations to which you need 100%
Right.
accuracy,
Could you
but which you don't
show the
have.
Skype picture
need
for,
more
for the
accuracy
benefit
than
of
Google
Lewis?
Earth.
With the
Because I don't think
blurriest
Lewis
photo
knows.
I've
sure.
ever seen.
Or elevation.
So I mean, if your initial point was, "Hey, Google Earth isn't that accurate with elevation," then I mean, we would agree with you. There isn't anything to
Great.
disagree on there. So
Great, you can have any value you want then. Put it in at 100. I'm happy with that.
Right,
So long as
100's
you
fine.
accept that
We
your
did
model
that.
doesn't do what
let's
your
do
model
it.
tells us it does.
We did that an hour ago.
Yeah, but you wouldn't.
we just
you
go
wouldn't
round and
admit
round with
that
these
your
guys,
model
and
was
that was
wrong.
another
Right.
point
That was
I
the
had,
point.
is that they're basically social vampires and they want your attention. And I think the more time we spend here, the more we validate
I
them.
think
And
you're right.
we
I
should
agree.
really just never talk to them again and try.
Yeah,
I know
that's
it's
right,
hard
Lewis.
because it's so much fun coming here and being right all the time.
I actually
But
learned a lot. From
if we just go
actually
to
trying
back
figure
to
this
our
stuff out.
lives, maybe we can try and be right in harder things and improve ourselves as people.
That's a very good point.
I think
Yeah.
flat earthers
Lewis,
should model the
pardon?
flat earth in like a movie, a CGI movie, and make themselves a fantasy movie.
Yeah, it would be really
Lewis,
nice if they
I want you to see
came
the
up with a
picture that you
coherent
claim
model
or that you were
that
laughing
accounts
at
for the
me about,
position
because I
of
don't
the
think you've
location of the
actually
sun,
seen
the
it.
stars, and the moon.
Yeah, I've got you
Just
up
for a
now,
start.
Anthony. You're sharing.
Well,
If
that's
you want to share your
possible.
screen on Skype.
Oh, right, okay. I thought
Big
you were just going
boss
to pull it up and
man.
open it. Hang on.
Come shake my hand.
Just give me
Lewis?
10 seconds just so I can share it with the Hangout as well. Oh, everyone's being sniped.
No.
Really, my
Is Lewis
concern?
still here?
Plenty of room on Skype.
Is Lewis still here?
Don't know.
Oh, he's gone.
Well, there you
Stop
go.
sniping
I've
people.
managed to make your screen shared now, which, in the meantime, after the panel went, but that's just part of the way it goes at the moment.
Well, Lewis, if you're watching, and I know you are watching, that's me in the picture right in the middle. That's the caravans that we're talking about. They are about 12 to 15 feet tall. How many caravans can you fit in there before it comes down to the rocks on the beach, Lewis? And does it look consistent with 20? I assert that it is, and I assert that Google Earth is probably right. But I also agree that the Ordnance Survey maps are also contradicting Google Earth. And I don't know what to go with because I'm a flat earther and I'm stupid. However, I'm only going off the tools that you guys give me to see whether or not your model does what you say it does. And guess what? It doesn't. That's about 20 feet. I agree with what it says on Google Earth. If it's something bigger than that on Ordnance Survey maps, it means that your map's wrong. But in any event, I'm happy to give you up to 100 feet on the observer height for a 50-mile observation. Because you need 1,000, Lewis. So 100 here or 50 there ain't going to make any difference. Is Nath back in?
Yeah, no, I'm still here. Everyone got sniped out of the hangout. So while you were in that monologue, I managed to load a whole new hangout, which is great. I'm just about to post the link in the in my live dashboard so the audience can see it and they can join again.
Well, it's usually a sign of being right.
Well, they don't like it when they. The thing is, Paul may well be right about the non-standard refraction. He may be, but I don't think he can prove it because he has to make up shit to get it right. He has to put values in, and if he claims it's all standard or whatever, then he's putting in standard refraction figures. By his own model, the effects are negligible. So he can't put standard refraction figures in. He has to put non-standard refraction figures in, and therefore he has to guess. So, how accurate is that likely to be? I'd also like Paul to suggest what he would like me to do measurement-wise for when I go back. You can tell me, Paul, what would you like me to measure? Because I can do the temperature pretty easily. What else would you like me to do that's reasonable? Don't come back with some flux capacitor hardware that I can't afford to buy. Just give me the obvious stuff that you want to know. Because I'll tell you something, Paul, it isn't going to make any difference. You still need 1,000 feet of observer height to account for that missing curve. GB, how are you?
Good. How are you? You've been killing it lately. Glad to hear.
I'm trying, man. I'm trying. I'm doing my best. But
no, you're doing. Calls... You're doing. You're not trying. You're doing. Yoda would be proud.
Damn snipers, man.
Especially the sniping efforts. It kind of is like it's refreshing, you know.
Sniper on deck has joined, and then who's going to be the first one out? Because I reckon Sniper on deck may well be the sniper.
Possibly. We've got Soundly back, and we've got Dawn Treader. Good to have you both.
Hello.
Oh, how do you remove the sniper, man?
Near Base, good to have you. You didn't get an introduction last time, Near Base. Good to have you here. Paper Explanator, good to have you here as well.
Oh, hi.
Yep.
Hopefully we'll fill it up to 10 and then people can't snipe the hangout if we get it up to 10 pretty quickly. We shall see. Tense moments.
I reckon one's just dropped, haven't they?
Nathan, how about like creating like a like either a hangout or a Skype group where you can post the links instead of posting them publicly?
Because this is what Google give me. Got to work with what you got.
No.
Pretty unsnipeable on Skype, no?
Yeah,
that means I've got to have everyone on a Skype list. I've got to be friends with all of you lot. Sorry, guys. No offense, but that ain't gonna happen.
That'd be so bad.
Well, you could do a hangout. You know, you could create like a chat room on Hangouts and just post links in there.
Yeah.
I want to show people this though. That's the truth. I want to show this happening. When we get sniped, if it wasn't for OBS, that would be the end of the show. I mean, yeah, we've got a bit of a kerfuffle while you all join, but this is what happens to loads of people who do Google Hangouts. Now, we can show that and people get to see it.
Google should get a hiding for it. It's ridiculous.
Like one line of code would solve it.
It's definitely a Google bug, no doubt.
Why does this happen?
Well, it's an exploit that Google is just leaving untreated, and despite all the porn bombing and all the complaints, every single one finds that the person who owns the channel is responsible for the porn bombing. That's their ruling every time, which makes kind of YouTube and Google complicit with exposing pornography to children. In my opinion, because they're not fixing this exploit, and this keeps going on and on and on. So to me, Google is just they're compliant with this type of thing.
They are.
So you have to work around it because they're not going to fix it. It's been 2 years now they've known of it, at least.
Oh, okay. Well, I'm new to this whole scene, so
So my
It's just an exploit. That's all it is. It's just a little an error in the code
it's
that
really
it's an
I couldn't
exploit.
believe how simple it was. I couldn't believe it.
Well,
A lot of channels are going down because of that too, and that just proves our point that we're making a point. We're getting somewhere, and we're proving the Earth is flat, and the only way they can fight us is character assassination or sniping and silencing us.
Even if Nathan has it up, he still has
So
to
why
keep up with.
Why then would they snipe Globers? They're sniping everybody, dude. Makes no sense.
They snipe the Globers for fun. I mean, not all Globers love each other.
Argument.
Ranty was going on about how, and no, it was Spurs Chemo. It was Spurs Chemo was going on about how the snipers were taking out the flat earthers, and I told him, well, I got sniped 3 times last night, and
Well, then I heard the excuse that it was they were getting sniped because they didn't.
Oh yeah,
want
what you have to
them
do,
get
Nathan, is
rest
just
or
add separate
whatever.
accounts till it's 10 each time. Just have Nathan.
We're not
1,
going
2, and
anywhere,
3,
so
fill
they
out
can
the gaps.
snipe all the way and
I think the guy just tries to go on and snipe who he can as quickly as he can, pretty much.
They could make channels like Tau City Alphas and wreck every single Flat Earth character. The information isn't going anywhere. You can take out all the characters you want. The information is never, ever going away. The truth is never going away. Snipe away. Snipe away. We're not going anywhere.
I wouldn't call it information.
Jibby, I mean, we've offered very solid arguments against flat Earth. Actually, falsify flat Earth.
We've offered very solid
you
arguments
keep
for flat
saying
Earth.
those. You keep
But
saying
we're not
those things,
sniping
but it
you
doesn't
guys.
make them
We're not
true.
suppressing your voice.
I could argue that the sky is not blue and profess it with ultimate faith and
But
the
say it all
sky
you
is not
want.
blue
We're
no
not
matter what
stopping you
you
from saying
blue
it. That's the
skyers
difference
say. The
between
sky's
us
not
and you
blue.
guys.
That would last for 2-hour argument about it.
Yeah. How do I
Front of
know
the sky
the
or
blue
something.
you see is the same as the blue I see?
Right, exactly.
Sky blue.
And
That
how
was,
many times have the flat earthers been
the black and
shown
white
to
room.
provide absolute nonsense and lies as evidence?
It's not nonsense and lies. It's actual things and tests
Well,
that
I
we
can
do
give
and
an
data that
example
we
of that
produce
here
that's very
right
neutral.
now.
I've yet to see.
You
a
guys
flat
have
Earth.
to add
I've
in your
yet to see a
gravity
flat
and
Earth
refraction
experiment that did anything but
to make
prove
it
that the
fit
Earth
your
was
model.
low.
Okay.
Yeah.
If you share my screen, you can see that during a recent hangout with Chris Monk, Anthony and Chris Monk were claiming that this object that we see on the screen here were claiming that it was Winky Lighthouse. They said, I remember Chris saying that they said that this was Winky Lighthouse, and he said you can see the white part of the top and the rail around the edge.
That's the one
they're talking
It's
about.
actually
You can see
a
the
vote, Paul. I
white
stand
part.
corrected. It's actually a vote. Winky Lighthouse
Right.
is actually just like to the left, and that is Ireland.
Yeah, well, I
in the
want to actually
background.
show you what Winky Lighthouse looks like. Winky Lighthouse is like that. It looks nothing like what's in the picture there. Okay.
Is that the one they were talking
what's
about?
in the picture.
How you doing, Chris? By the
Yeah,
way,
like
good
that's
to have
what
you.
they're talking about. And guess what we reckon it is? It wouldn't happen to be the ferry that goes from Douglas around to Ireland, would it?
Couldn't
that
be.
we see in that picture? Oh, no, it couldn't possibly be that what we see in there is actually the boat going from Douglas round to Ireland and not Winky Lighthouse, which looks completely different.
Which,
to what
mind
they
you,
see
the
and
person,
what they say.
mind you, the person photographing that or videotaping that would know that it wasn't a lighthouse.
Yeah, that's right. So we
Well,
get this
I was the one that
nonsense
filmed
and
it, and we
lies
couldn't
from
tell if it was a
all the
lighthouse, a
time.
boat, or something else.
Excuse me. Can I just point something out regarding what standard means in a lot of circumstances?
Okay.
Not really, because you think the stars are like millions of light years away, so I'm not sure what you could add to it, to be honest. And to be honest, the issue's not about what standard is.
Actually,
The issue was how do you prove it?
And in science and in medicine and things
Paper.
like that, we
Paper.
have to.
The issue wasn't
draw
what
a
standard
line.
is. The issue was how do you prove it?
Draw a line, what we call standard. Okay, it doesn't mean that everyone has to or everything has to comply to that. It is a defined standard. It's a little bit like body temperature. Body temperature is defined as, for instance, 98.4 degrees Fahrenheit. Okay, that is standard body temperature.
Shannon Q made that point.
Take your baby into the doctor's surgery, and he takes your baby's temperature. It's 98.4. It's fine. If your baby's
Paper.
temperature is 98.5, they don't ring the ambulance. Okay, they go, oh well, it's okay. It's up by 0.1. 0.1 of a degree Fahrenheit. That is non-standard. That is not
Yeah.
standard body temperature, but it is of
Do you know what,
very,
Paper?
very
I'll agree with
little
you.
relevance.
I'll
Very-
agree
let
with you,
me-
Paper.
let
The
me-
issue is
let me
not
just-
what is
please let me
non-standard. The
finish.
issue is how can you
Please let me
prove it.
finish. That is defined as non-standard body temperature. 98.6 would be defined as non-standard. If it's 102, they ring the ambulance. Your baby is about to die. Okay? So there are differences between standard, non-standard, and extreme. Okay?
Yeah,
So
but
when
Paper,
we say
listen to me.
standard
Answer this
refraction,
question.
okay, we have 0.17
Paper.
was defined.
Okay, I think-
0.18 would be fine as well. When it gets to something
Paper.
like 2.6, you start to get Fata Morgana, you start to get looming, you start to get very, very unnatural, unexpected things.
Just the boiling point of water, I mean, is a good example.
Exactly.
Aye, but let me ask you this, Paper.
Define-
Paper explanation. Listen.
Referred to as STP in science, standard temperature and pressure. It's like when you
Yes.
say the reaction rate of a particular chemical with another chemical, you say it's X
Paper.
amount per second,
Paper,
whatever,
listen.
at STP, standard temperature and pressure.
So I think
You increase
Anthony
the
has a
pressure,
question.
increase the temperature, whatever, then things change.
Okay,
Paper, listen.
let's let Anthony
No,
talk for a
nobody disputes what standard means. We all understand that. The question that was being asked was, how can you prove that it's something other than standard or non-standard? Where do you draw the line? How do you know what is this? Because I'm a flat earther. I'm stupid. How can you tell me for future?
Right, I'm going to interrupt Anthony just to do a few links. So we have approximately half an hour left on this stream. So if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you would like to support this channel, there is a super chat that runs alongside the show while it is live. And most importantly, if you would like to join the debate, if there is a gap that opens, simply click the link in the info box below this video. Be sure to mute the page you are currently watching before you do so. There are a couple of rules in the Hangout. Number one, please do not swear. If you do, you'll be ejected, and if you are, please do not try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. As I've said many times on this stream, please share the shows. It does increase the live audience, of course, and that in turn increases the likelihood of a more diverse panel. One last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.
Semantics. You are. I think you're practicing your trade at trying to pull people up on words.
Master of equivocation. Yeah.
Yeah.
Right. So can you prove a definition? That's my question. Can you prove a definition?
Yeah. In what respect?
No, that's just generally speaking. Do you prove definitions?
No, definitions are made that
Exactly.
fit with a current
So
with an accepted model.
Right. So a standard value is a definition.
No, it's
and so therefore
it's what is defined as an expected value. So that if you were to go out and make a measurement, and you take all the measurements of the temperature, pressure, temperature inversion, air pressure, etc., and they were all exactly as what is defined as those figures, then you would expect to get the result defined from that.
Right. So
if
I'm not arguing. I'm just.
Then you'll get slight variation.
Right. So what I'm saying is that I think what Anthony is trying to do is trying to make us prove that standard is standard. And the problem is standard by definition is standard. Anything that is not standard is not standard.
Yeah.
Seems pretty self-evident to me. Jesus.
Aye. But the problem I've got.
I mean, I'm really talking about this.
The problem I have is that Paul
just have to make this extremely clear, I guess.
I suppose. Yeah, I know. No, I know.
You have to define the assumptions before you can make any arguments.
Hold my nose here, get a reality check.
But listen.
Riley, do you trust that there is such a thing as refraction?
Me.
I think he has to.
I don't think he's here.
This is the problem Anthony has. The 7.6 measurement is saying that the Earth, in normal conditions, with normal atmospheric conditions, behaves. Light behaves, and images at the horizon, etc., behave as if the Earth was 7/6 times its actual size with 0 atmosphere.
Actually, it's apparent size.
Yeah.
Not its
apparent-
actual size,
what
apparent
is-
size.
what-
That is the
apparent. Do you know the definition of the word apparent, Anthony? It means as
Yeah,
in
apparent.
appears.
Claimed.
Yes.
Yeah.
No. It means
Apparent.
apparent from the word appears. It appears.
Well, it would be the opposite of factual,
No.
wouldn't it?
When you no. It means that the Earth appears to have a radius 7/6 times bigger than it actually is. That means if you to take
No,
our
that's
Earth,
not
then
correct
take
at all.
an
Do you
identical
want to
planet,
rephrase that? That's incorrect, Paper.
No, it's not. Imagine taking an identical planet, and then you expand that planet to have 7/6 the radius, but take away all of its atmosphere.
Yes.
The images that you would see on each planet would be identical.
Exactly.
Right. But do you agree the word apparent would be the wrong adjective?
Yes, because it's apparent, because
shouldn't
the
it be
Earth's size
actual?
doesn't change.
How is
it gives
what-
an apparent effect.
Yeah, I mean, apparent means it's just how it
What
appears,
is
how you
apparent
observe
to you? It is what appears to you. I think.
Right, that
whether
isn't
it's
what
right,
it
right,
says.
Do you realize that things can
Paper, that's
appear
not what it
differently
says.
than they actually are?
Yes, they appear differently. When you drive along the road, Anthony, on a hot summer's day, okay, and the road is straight ahead in front of you, and you see what appears to be water. On the road, it is apparent that there is water on the road. It is apparent. It's not factual. There isn't really
So
water.
that's my point with the radius.
There isn't really water on the road. It is, but it is apparent that there is.
Riley, I know
So
you
just-
ignore me. You ignore me. I'm going to say I think there's good possibility you're paid to be stupid.
No.
Your behaviour is so strange. It's strange. It's like unexplainable behaviour.
No, it really is. It's quite unexplainable.
Practicing his abilities.
It's like the best psychologist ever is going to have a hard time, like telling you what is what is wrong with your mind.
Anthony is practicing his abilities as a defense lawyer. He's trying to defend the indefensible.
He's doing a very good job.
Well, all you got to do is show any person that he wants to be a law for
Let me
one
read
clip of
what
him
it
on the
actually
internet.
says
and
for the
that's
apparent
ruined for him.
radius.
Here's what every lawyer does.
Paper.
Obviously,
Paper. Let me read to you what it says for the apparent radius, and you can tell me where I've got this wrong.
No,
Mick
I don't wanna hear
West's
that
own
shit.
words say the value of 76R is a rough approximation of the effective refraction on the apparent radius of the Earth, not
To what
a
end?
superficial
To what end,
7/6.
To what end?
It's
That's
based on
exactly
the
what it
apparent
says.
radius, and my assertion is the
We've
apparent
spent an
radius should be a
entire
proven,
year collectively
factual
means, Anthony,
evidence.
that
pointing out point by point, inch by inch, every single thing that you've been wrong about. It's like an amazing collection of work that you have, Anthony, where you have been wrong on
Well, the
literally
problem is
everything
your
that
model
you have
doesn't
said
stand
for
up to
the entire
scrutiny,
year.
whereas my
How do
evidence is
you
standing up
trust
to
your
scrutiny.
own judgment? That's what I want to understand. Because your judgment has been proven to be completely bunk.
It means, Anthony, that the Earth is apparently 7/6 times bigger than it is.
No,
If
that's
you
not what
assume
it's
that
saying.
there's
Let me
no
read it to you again.
refraction at all.
Paper, that's not what
Not
it's
so
saying.
much
Let
a
me read it
body
to
of
you
work,
again,
but
and
a
you can
stinking
interpret what it
corpse.
says. I'll read it to you again for a second time because you've missed it.
You do
The
realize that
value-
light rays have to
The
go into
value
your
of
eyes so you can see
76R
them.
is a rough approximation of the effect of refraction on the apparent radius of the Earth. Can you
Yes.
tell us what that means for a second time because you've messed it up already? Well, for a third time. Paper, what does that mean?
That means you're wrong again.
No,
Anthony.
you failed to understand what it means.
It appears from calculations and measurements to be 7/6 times bigger than it is.
No, that's not what it says. That's not what it means. You've
What it
misunderstood.
means.
You've
You have no
misunderstood what
idea
it says.
what
What it's
the
saying
meaning
is the
are.
effects
You
of
know how they
refraction
actually
on the
calculate the
apparent
curvature?
radius of the Earth. In other words, it's based
Do you know
on
how
the
they actually
radius of
get
the
the
Earth,
refracted
but it's an
So what do
apparent
you
radius.
think it means, Anthony?
Get in?
That's
What
what
do
it
you
says, and that's what it means.
What does it mean? What are you saying that says? Are you saying that hidden within those lines are the Earth is flat?
No, what I'm saying is the calculation for 76R is based on the radius of the Earth, but it's an apparent radius. It's not a proven, it's not a factual,
How
it's
it
not an
appears.
observed, it's not an evidenced, it's an apparent
R
How it
is the
radius.
apparent radius.
apparent.
R is the real radius.
It's an
R
apparent
is
radius by
the
its
real
definition.
radius
Nathan,
of
could
the
you
Earth.
share my screen so that these yahoos can see it? They
Yeah,
obviously
what
don't
are you
understand
getting at,
when I'm
Anthony?
saying it.
Anthony. Well,
Anthony, if you share my screen, you'll see where they calculate that apparent radius from. The apparent
No.
radius calculation is done down here. And to do that apparent radius calculation,
There you go. Thanks,
what you
Nathan.
need is
Right,
the
Paul.
refraction coefficient.
Right, Paul. So maybe you can do it for us because Paper Explanator is unable to tell us
We
what
sure
the
know you
refraction
can.
means. The value of 76R is just a rough approximation of the effect of refraction, which by definition is negligible, on the apparent radius of the Earth. Focus on this bit, Paul. What does this mean?
Showed you how that calculation was done just before.
I don't even think it'd make a difference.
Based on what,
I
Paul?
literally
he's not
showed
getting it.
you, Anthony,
He's
where
never
that
going to
calculation came
understand.
from.
There's
Is it
no
based
way.
on a proven radius?
It'd be nice to see Anthony doing
The
the calculation.
radius is required
Or is
in
it
order to
apparent,
determine the
Paul?
coefficient. Is that how I'm reading it properly?
If Anthony does a calculation, I will bow down and call him master.
I'd quite like to hear what Chris has got to say. He's been waiting patiently for about 20 minutes. So,
Calculate the apparent radius.
sorry, Paul. He didn't even get an instruction.
sorry.
How you doing, Chris?
I was just going to say, if Anthony could do the calculation, I'll bow down and call him master.
Not you, Chris. You've had plenty of introductions.
All right. Okay. Piece of shit.
The other Chris. How you doing, Chris? Good to have you here.
Good. I just had a question for Paul here, since he was kind of citing some of the work I'd done previously.
Yep.
The assumption of the radius is a requirement to actually determine the coefficient of refraction. And if the angle of incidence is 0 to the target and the angle of refraction is 0, then there is no refraction. So I'm wondering how that works
nonsense
in his model.
Wait, say that.
Well, if you're looking in a straight line to a target from at the height, and the actual focal point of the lighthouse is 213 feet, then the observer would have to be at 213 feet on a level line to see it. So how do you make up for that loss of curvature in your model?
231 feet.
Ray doesn't go in a straight line.
213 feet, and as well as that, Chris, you know very well that the light ray passes through different layers of atmosphere as it goes, and that means that it bends. What you're saying is a load
If there's
of
a difference in
absolute
the
nonsense.
angle, if there's a difference in the angle of incidence versus the angle of refraction, sure.
No,
But
actually,
if the
it
light
would-
ray is
it would actually
a
bend.
straight path,
It would
no.
actually bend on a flat Earth. The variation in the atmosphere causes the light to bend because the light takes the fastest path between the 2 points.
Yes,
So
if there's
it's
an angle of
the-
incidence, if the angle of incidence
no,
is
no,
0
no,
and the angle of refraction is 0, otherwise the light is a straight line path. There is
That's
no
assuming that you have
refraction.
homogeneous materials
But
on
your
either
fallacy here,
side of
Chris,
it.
your fallacy here, Chris, is that the light rays that are coming straight to us are the ones that we see. That's not true.
Yes.
Okay.
Yes, exactly.
So when you shot a laser through air, it bends, is what you're saying then?
It does.
Yeah.
Do you have an
does,
experiment to
doesn't
show
it?
that? Then how is
on.
the speed of light determined? If the
Hold on,
light is
hold on.
bending through air, then the speed of light cannot be determined, nor the degradation of the speed of light in the waveform.
Actually,
Sure,
Chris,
you
the
put
other
in the
thing I'd
value.
like to point out- The other thing I'd like to point out, Chris, is that importing two-dimensional images into Blender doesn't make a three-dimensional model.
Well, it actually is a three-dimensional model.
No,
It's flat.
Sure it is.
not.
I'm not even sure what you're
And
talking
as we've
about
pointed
now.
out just before, you misidentified Winky Lighthouse.
Do you believe in? No, it's actually about Winky Lighthouse. It's slightly to the left. It's just a little tiny black
I
thing.
wasn't
but the line of
talking
sight
at
is
all,
actually
Chris.
straight
I wasn't
through.
talking at all, Chris. I wasn't talking. So I was going to ask you, do you believe in glasses? Do you think glasses can actually correct people's vision? Do you believe that?
Can we weaponize lasers?
But I'm asking you that, Chris, because refraction is what causes that. Okay, that's why glasses can fix people's vision because of refraction.
Yeah, but
so
that's
it's a
going
real
through a
thing,
change in medium, though, right?
and we know how it works. We know
Air's
how it
medium.
works.
Yeah,
know
we
how
do.
works.
It goes through a
Whenever
change in
light
medium.
travels,
It applies
whenever
Snell's
light
law.
travels through a medium, it between or crosses the boundary layer between two mediums. It
Snell's law.
bends towards the more dense medium. I mean,
Yeah,
we
that's
know
what
that.
application of Snell's law applies
We
change
know that's
in
how it
medium.
works. Okay, so we know how it works. So
It bends away
that
from
the
it.
atmosphere, we know that the atmosphere is more dense, lower down, in typical standard situations. So that's how you know. I mean, you can show it
Yeah,
through
but that
experiment.
applies Snell's
So I don't
law,
even know what
and
you're
it
arguing
requires
about.
a change in medium. Where's the change in medium, Soundly?
Snell's law is a specific example of Fermat's principle.
No, it isn't at all. That's ridiculous. That is not
No,
an
it is.
example of
It
Fermat's
is.
No,
principle.
what you're saying is ridiculous.
Can we pin down? Can we pin down how many feet refraction's got to account for? Because I still don't know that.
Loads.
It's really pretty simple. If the lighthouse
if its focal point is 213 feet, then obviously you couldn't see it unless you're at 213 feet, same elevation. It'd be below the so-called
Okay. What? So 100 feet.
curvature.
About 100 foot.
You just
I
literally
thought we
explained it to
determined.
you.
I thought we determined
like
based on
10
the
seconds
adjusted
ago.
observer height that it was pretty much spot on. I think that's what Paul was
It's
saying.
actually
earlier.
not. It's still.
I thought that's what it was.
It would
earlier
still.
as
It would
well.
still be over 100. It would still be over 100 feet below the observer, even if the observer was at 100 feet and the focal point of the lighthouse is 213. Do the calculation.
It is a video showing.
It's not correct.
When you asked for that, they
321 or 324 feet of the so-called curvature, refracted curvature, even using refraction, still puts the lighthouse, well below 100 feet below the horizon.
If you're going to talk about refraction for this long, you need to work out how much it's doing, what it's doing, how many feet.
I created a non-standard refraction calculator if you want me to plug in some numbers to it.
You'd have to guess the numbers.
Well, actually,
that's the problem.
Chris, at 31.5 miles to Morghold Lighthouse at an observer height of 100 feet, there is actually only 190 feet hidden.
So it's still
The
hidden.
lighthouse
Still
is
hidden
200
then. Still hidden. So we still haven't brought it back. Still Earth
Still
curve in
hidden.
the way then,
No.
Paul. We're back to the point that Brenda made.
Actually, it's not all hidden. It's actually not all hidden. And we only need to account for about 50 feet.
So it is hidden.
And I like
By
to point
50
out too.
feet.
I like to point out too.
Hold on,
I
Paul
like
is
to point
just
out, too, that
lying. He's
50
just said it
feet-
isn't hidden, but we have to account for 50 feet.
Hold
Hold on,
on,
Paul.
I'd like to say
If it's
something
not
here about the
hidden,
50 feet.
what are you accounting for 50 feet for?
I like to point out something about 50 feet because
No, Paul's just lied, and I want him to establish this fact that he's just said, no, we don't, we can see it, but we only have to account for 50 feet. 50 feet of what, Paul?
I'm going to point out that 50
No, Dawn,
feet
let's just
on
hear
the
Paul
target
say
end,
what we're accounting
50
for.
feet on the target
Dawn,
end is
no
only a difference
need,
of
my
about
friend.
5 feet on
I
the
want
observer.
Paul to say it, because he's
That's something that
dishonest.
no one will ever talk about.
I want Paul to say it, because he's dishonest. What are we accounting? What's the extra 50 feet you're talking about, Paul?
At all, Nathan.
No, we're all trying to come up with a number, I guess.
No, we're not.
No,
We can all,
obviously we're not gonna
us on the
agree on
flat
it.
Earth side, Dawn, can just see the lighthouse. We don't have to come up with any numbers or any explanations or any nonsense to account for Earth curve that's not there. We don't have to do that. We simply say we can see the lighthouse because we have line of sight with it. Simple. You guys
Yeah, and
have to
also, we
account
simply
for an
can't see
imaginary
all of
curve
them,
that
can
isn't
we?
there. And every time you fudge the figures, you still have to say it's still hidden. You've fudged the figures and it's still hidden. It's still hidden. It's still being blocked.
Nothing fudged about this. Nothing, Oakley.
Still hidden. You've just put it up on the numbers and
Yeah,
said
I don't-
we've
I
got
don't
50
mean the
feet we have to
general
account
refraction
for.
feet. I mean, how much on that image?
It's hidden by the Earth. It's in the way. There is no way he can get around
And we
this.
told you that refraction accounts for that, Nathan.
Right, so we don't have direct. So you're going to admit it now, Paul. It's still blocked. Paul, fact, it is still blocked in your model by Earth curve, correct?
It is not.
No, it is
Yes,
not,
it
because
is.
our model includes refraction, Nathan.
Yeah, you can see it here. It says quite clearly how much is hidden by the
You
Earth.
are going to use our model, Nathan. Use it correctly. Our model includes refraction, which
Yeah,
includes
but you can't prove it though, can you,
non-standard
Paul? That's the
refraction.
point.
Nathan,
You can't prove the
if you are
refraction,
going
can you,
to
Paul?
use our model, use our model
Hey, thanks for having me.
correctly.
Paul, you can't.
So
prove
just,
the
I just want to be, I
refraction,
want to
can
be
you?
clear here. So let's say that the model that's being cited by Paul is including refraction, right? So this refraction is obviously having a dramatic difference on the appearance of where objects appear in the atmospheric
Let's see
refraction.
the lighthouse on this.
So what effect does this have on the sun, the moon, the stars, and how was the determination of their distances actually calculated in the first place to determine the radius of the Earth?
No, we're not talking about that, Chris. We're talking about the Isle of Man.
Where's the
Don't
lighthouse
shift
on
the
this?
goalpost.
So refraction can only affect lighthouses and not the stars and moon, Paul? Like what's going on
No,
here?
but we're not talking about stars and moon and other things. Chris,
So that's the lighthouse, yeah.
we're talking about the Isle of
What are we saying?
Oh, I see.
What's the average for refraction of how many feet that bends, like when it's not standard?
Well, it depends on what the refraction coefficient is. It would
Depends how
only
much-
take
depends how much Earth curve's in the way and how much they need to account for.
above normal.
Depends how much imaginary curve gets in the way. If there's loads of imaginary curve, they have to make up lots of
I
refraction.
did it the other day. It would
Nathan, what
only
about
Why
parts
is
of
the radius
go
required?
further down the island that are like 50 miles away?
I
Let's
got
focus on some of them.
the radius. If you want me to show that, I created.
Why is my question is, I have a question though. Why is the radius of the Earth required as an a priori assumption in order to determine the refractive coefficient. Why do you need the radius?
Yeah, what's it got to do with it?
Because we know the Earth curved.
Yeah, but what does it have to do with it when the only real value that's variable is the amount of moisture in the atmosphere? That's what changes what we see.
Can you not accept that like stuff changes when on your vision on Earth?
Well, if you're actually including the radius as an assumption, then you're changing the figures to the result based on that radius.
No, absolutely not.
See, there can be independent measurements of the radius of the Earth, right? This is not the only time that the Earth has been measured.
There's variables everywhere on Earth. In everything you look at, there's variables in nature.
But why is the radius of the Earth even relevant to what we see across the atmosphere?
Because you need to be able to measure where the light goes. You need to be able to predict where the light goes.
The only four things are pressure, viscosity of the air, the gas molar law, and the other one, whatever the other thing. Doesn't talk about the radius. Why is radius?
Let's say refraction accounts for 1,000 foot. Yeah. Why can't you just accept that there's variables in nature?
Yeah, but there's only four variables and none of them are at radius.
What?
How many? If you want to argue against the model, then
the position depends on the radius.
If you want to argue against the globe model,
Let's
why would you be arguing about
refraction
the
accounts for
radius?
10,000 foot? Yeah, and just think
if
nature is variable. Why is that hard to understand?
I'm sorry you broke up then. I didn't quite catch what the first couple of words were. Ask that question again.
I heard him fine.
Let's say
I heard him fine too.
Lily, by name, by nature.
Are you going to ask your question again or not?
I don't think he
Okay, I'll ask it once more, yeah. Let's say refraction accounts for 10,000 foot of missing image. Why can't you just accept that nature is variable? Stuff changes.
I can. And we know what the four variables are.
Four variables.
None of them have got anything to do with the radius. It's the temperature, the geopotential altitude, the pressure the vertical pressure variation, and the ideal gas law in molar form. They're the four variables.
How many times do we have to go
doesn't
through
mention
the same
anything about
song
the
and
radius.
dance,
And it doesn't
Riley?
mention anything about the
This is
radius in
pathetic.
anywhere else in the document. So again, the
This
question
is
is why is there an assumption based on the radius?
Can we make flat Earth bingo or something to come up with new subjects?
I just want to point out
So
that the
now it's
radius is
basically
in
at the
one of the equation.
Sorry, go ahead.
It isn't, no.
We
It isn't.
experience flat and motionless.
You
See,
experience
R. That's radius, so it does account for the radius. I just want to point that out.
No, it doesn't. Nowhere in the non-standard refraction does it account for radius. Only on Midwest site.
Only R. That's R.
That's an
R is
absolute lie,
radius.
Riley.
Only on
R, that's
Midwest
radius.
site does it count for radius. Nowhere else does it do it.
What do you mean?
when
It's
you
just
calculate
R.
the path of the light ray, you need to know the radius
Yeah,
of the Earth.
for the coefficient you don't, but for the radius, for the relative radius, you need the R, which is radius.
Look, the
Sure,
model
the
assumes the Earth is a
geometry.
globe. Okay, fine. Like I do prove the Earth is a globe without,
So you're saying that the light, basically, if I understand what you're saying, there is the light is actually following the geometry of the curved surface and going around the ball.
Somewhat, yeah.
Yes,
can
the
do that,
atmosphere. The atmosphere has the spherical geometry.
Right, and you're saying that the light is
Where?
following that path.
So yeah,
Whatever path it
Under
has
the
to
right
take
conditions,
from
it
point
can.
A to point B.
Absolutely.
So why do we have nighttime on the dark side of the
spherical
Earth?
geometry on the atmosphere. It's
Wouldn't
very
the
it's
sunlight
a flat
go right
globe
around it?
from high
Completely
altitude.
around it perpetually?
it does a little
On
bit.
the
It does a little bit.
Yeah, what, at
exactly.
the
It's
edge
not
of
a
the
perfect,
frame? That's
More than
standard on every camera
50% is
on ground or in the
illuminated.
sky.
Due to refraction, yeah, that actually does happen.
What was your
Which is
question,
why-
Let me
Chris?
ask.
I didn't
let me
actually
ask,
hear
if
the
it-
question.
If light follows the curve of the Earth, then Paul, does that mean in the right circumstances and a powerful enough telescope, you could actually watch your own arse as light travels all the way around the Earth?
No,
That's
it
what I'm
doesn't.
saying.
No.
Yeah, absolutely.
Um,
It was
Theoretically, but we do have things called mountains and atmospheric thickness.
Theoretically, with a clear enough day and a far enough zoom and Paul's maths, you could see your own arse.
I did calculate that.
theoretically,
But
so
find
that's
out what the
good.
density would
So
be.
is
I
there
can't
any
recall it,
evidence
though.
that
I don't
shows
think-
that
yeah.
light will follow or
Conditions
conform
for that
the shape
are
of
like
an object?
impossible.
Is there any evidence that shows that light can't even follow the exterior? It's like water. Is there any evidence that shows that light or water can conform to the exterior of a shape?
Yeah, the globe.
Yeah.
With the water. No problem.
Self-evident it must be because it's a globe. It's back to this. Self-evident it has to be.
size.
So basically, we can apply Dell's principle to
Well,
light.
Nathan, what they're trying to say is that the light is following the path of the curvature of the Earth, following the atmosphere. And so the sunlight is actually traveling around, following the thin film of the
Called
atmosphere.
atmospheric science. You should look into it.
No, that's a fallacy because the sunlight. That's a fallacy because the sunlight is coming in from external. It's going through different layers of atmosphere than what we're talking about here.
And you typically have
absolutely an inappropriate analogy.
So the
1/2 degree
curvature of light
displacement
only
with the
applies to
sun.
things that are on the horizon and the lighthouses and so forth that are playing at the
No,
level of our
no, not only.
existence, but doesn't apply to the sun.
No, of course.
That makes absolutely no sense.
The sun is displaced by refraction. Yes.
Right.
And how do
Actually,
you
read this
determine
paper.
it?
Typically about a half a
Read
degree
this
near the
paper that
horizon.
Riley cites. They actually
Well,
talk
allegedly.
about this in great detail. The paper that Riley
So then, what you're
cited.
saying is where the sun appears in the sky is not actually where
Exactly,
it is.
yeah.
It's
Go
following
to that
the curvature.
Near the horizon, that's true. Yeah.
Whoa! You understand something? Yay!
Well, there you go. So how did you actually accurately calculate its distance to determine the radius of the Earth if it's not even where you think it is?
Because we used the
When it's
transit.
near the horizon, it's about a half a degree displacement,
Right.
Chris. The higher in the sky, the
The
less the
day.
refraction.
Right, because the rays are coming straight on.
Mong. Frickin' Mong.
Hey, Chris Monk. Can I talk?
Hey,
to you?
how's it going? Yeah, for sure.
Yeah. Hey, yeah, I remember at the times with the Sun and Moon when you were on that you're very much into CGI. You're very good at that, right?
Yeah, sometimes I get into it. Yeah.
Cool. Because I was wondering, could you perhaps help me, maybe through Skype or something, we could talk on how to make a CGI model for how the perspective works, so I can actually map out the ideas that I have. I think
Do a flat Earth horizon CGI model.
Yeah.
That'd be sweet,
Space-
man.
Variable
Yeah.
space density and stuff.
Well, I've already have all that.
it should be pretty basic to work that out if you have a advanced enough.
Well, it is pretty
ray
basic.
tracing.
It's pretty basic, and I've already done it. Actually, I have a working model that shows all
Yeah,
that.
add
already.
in refraction if you want as
With
well.
working
Cool. Could we
model?
talk about it? Do
A
you have
working model? How loosely are you using the term working there?
Okay, yeah.
It's basically a flat plane with the anisotropic properties of light.
I just want to see it
right
work
next to
in
the light
graphic
density.
form. That'd be cool.
0.065, per meter squared. It's all programmed in.
And you should show that sometime, Chris. Let's take a look at
Yeah,
that.
well, I can, yeah, for sure. I can't load it up right this moment here, but I can, yeah.
That's okay. We'll do it when you have more time to give a proper
that does sound-
demonstration
that
of
sounds
what you come
cool.
up with. Very interesting. Look forward to it. I hope you come
I
back.
did one actually too that models the actual spherical Earth to its actual proper sizes too, with an atmosphere, and it shows that where you're looking through your telescope or camera at the horizon line, at the terminator line of the Earth, you're actually looking more towards the equatorial line. So the sun is actually not where you think it is anyway. It's not a straight line.
What are you trying to say?
Wait.
You sound utterly confused.
No, it's just you
If
sounding
you're-
ignorant.
If you're standing on the terminator line of the half-lit ball, in simple terms, looking towards the sun object at 93 million miles away, the angle of the camera is actually looking towards the center point where the hot spot would be, and so you're not actually looking at the sun. It appears to be in the sky.
No, the
Or
hot
fixed for you.
spot, as you call it, is not the subsolar point. You're not going to see a reflection at 6,300 miles away, Chris. A reflection is
I'm
going
not
to be
saying- I'm
closer
not
to
saying you're
you
seeing
where
a
the
reflection.
angles work out. But when you are looking at the sun near sunset, the subsolar point is about 6,300 miles away from you across the surface of the Earth. You realize this, don't you? And you're not looking like a line that Jaron draws
Correct.
on his stupid demonstrations on Google Earth, where he draws a great circle route with an initial heading of your line of sight pointing towards the sun. Your line of sight does not lay down across the globe and follow it downward. It's a straight line out to the sun. where your line of sight and other people's line of sight at the very same time to the sun are virtually parallel, not crisscrossing down across the surface of the earth near the equator or wherever else
it's not a straight line of sight. If you're standing at the Terminator line and you're trying to look at the sun,
it's a straight line of sight to the sun.
No, it's not. No, it's not.
You're not looking at a point on the earth, Chris.
Yes, you are. You're looking through the atmosphere where the sun appears to you within the medium that's refracting
But you're not
the light.
looking at a point on the earth, Chris. The horizon's a few miles away. The subsolar point is about 6,300 miles away. The sun, much further away than that. And you're looking at a line of sight, straight towards the sun, not at a line curving downward on the ball like Jaron traces out on Google Earth. That is absolute poppycock. That's an outright lie what he demonstrates on Google Earth.
I'm not familiar with his demonstration, but
he's demonstrating what you seem to be describing.
I haven't seen it, so I can't comment to his model or what he's describing.
I guess it's probably variable.
I have no opinion unless
So what do you have to say about the subsolar point being about 6,300 miles away at sunrise or sunset? When you're on the Terminator line, that subsolar point's about 6,300 miles away. What do you think of that?
Well, I'd have to look at what I got modeled and calculate it and verify what you're saying.
It doesn't sound like English to me.
Why don't you look at it? Why don't you look at that?
Yeah, I will do so, yeah.
It
In the interest of science, absolutely.
Think like if we could develop some weaponized lasers, like ISIS wouldn't be
I
able
think
to do
we have
anything
weaponized
versus
lasers.
that.
What?
Do we not have weaponized lasers?
I think we do.
Directed energy weapons.
I'm not going to
Conspiracy theorists love them.
There's probably some on satellites and that.
I'm not going to
1 minute left, guys.
Pointing down.
Guys, just one last request. Paul, I'm still waiting for your evidence for molten iron showing properties that will self-perpetuate. So when you're ready, I'm going to keep asking you for it.
All right, this whole thing. Oh yeah, that was pretty interesting.
Like it's serious.
At least we got off the.
Every time I see you, I'm going to ask you for it.
It's amazing how a flat earther can just change the subject, but we can't, eh?
I'd like to know how Anthony Riley thinks that the core is powered by electricity via a non-conductive molten iron medium.
I want just a little statement
It's
from Anthony
required
about
in
how
the-
he's going to
it's
feel about
required
the
in the
award.
definition of
How he
inductive.
feels leading up to the award ceremony.
Riley claims it's non-conductive yet powered by electricity externally.
It's required once the Curie temperature is met, curved. But you wouldn't know about that because you don't understand what you're talking
How
about.
is it powered electrically if it's non-conductive, Riley?
That's my point. It's a contradiction, curved. I know you don't understand it, but that doesn't make it so.
And with that, I'm going to say, first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and, of course, for sharing this debate. And a massive thank you to all of the debating panel for making this debate possible. Be sure to like, comment, share, and subscribe. I've been Nathan Oakley, and I'll see you all in the next video.